Hide the planet! Hide the planet!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat. And we're doing HackerFrogs free hacking today. We're doing HackerFrogs after school. We're hacking all the things. So let's talk about what we're going to be covering on today's live stream. Typically, we like to do a number of different topics on each one of our live streams. And today is Wednesday, June 24th, 2026. And we're going to be covering a few different topics. The first topic we're going to be doing for the first hour is going to be Order of the Sinking Star. It is a puzzle game that has a demo out right now, and it's a very widely anticipated puzzle game that has been in development for about 10 years. And we're going to be checking out the puzzle game and seeing how fun it is. So that's the first hour of today's stream. In the second hour, we're going to be doing some demos for some easy cybersecurity challenges. So the easy cybersecurity challenge we're talking about today is, well, it's not PicoCTF, but it's going to be Hack the Web. Hack the Web is a very fun, beginner-friendly cybersecurity game where you can solve challenges to learn about different cybersecurity concepts. In this case, they're more like tech concepts in general, and we're going to be covering how to do some of those challenges today for the second hour. In the third hour, we're going to be doing HackerFrogs After School, which is a little program that I wrote up that teaches about a bunch of different cybersecurity topics. And in this case, we're going to be doing our network hacking course. We're doing session number 2, which covers a bunch of common networking services and how to interact with them. Cypher on YouTube. Hello, good morning. Good morning to you. It must be Europe it must be Asia where you are, if you're saying good morning. Cypher, hello, nice to see you here. And the last topic we're going to be covering today is we're going to be doing a cloud hacking topic. So this is HackSmarter's Data Secrets module, which deals with AWS, Amazon Web Services, and how to do security testing against that platform. So that's probably going to take maybe 2.5 hours or so, and that's going to be the last topic we cover on today's stream. Cyphers is good enough, and Lucano, hello, nice to see you. Lucani, hello, nice to see you here on YouTube. And let's go ahead and get into our warm-up topic, our gaming. Let me go ahead and put 60 minutes on the clock, and we'll get started. If you're interested in the next topic, you can see the current topic and the next topic in the top of the overlay. It's Luca. Oh, Luca. Okay. Luca Nicole. Okay. Thank you very much for letting me know how to pronounce your name. Anyways, I'm going to start up the game, and we're going to be playing for about 60 minutes or so. Nicolescu. I hope I pronounced that correctly. Anyways, let me go ahead and start up the game. You should be able to see it in just a second. Over here, okay, and we're going to be doing the temporary computer-generated voices, just so that I don't have to talk as much. You should be able to hear the game as well. Let me see if I've got the... Yeah, so you should be able to hear the game. Alright, and let's go ahead and get started into the game. So, in this game, what we need to do is we need to guide each one of our characters over to these tiles over here, these orange tiles. And of course, each one of our characters has a different special ability. So this character, this yellow character, their special ability is that they are not harmed by monsters. Okay. Luca asks, am I able to follow along? Yeah, I mean, if you wanted to get this game, it's, I think it's available for free right now over at Steam. Let me go ahead and see if I can pull up the page. Okay, so over here, you should be able to download the demo. And the demo actually has a lot of stuff in it. We've already been playing this demo for about an hour or so. Or has it been like 2 hours? We've already played 2 hours of this demo, and we still haven't run out of stuff to, well, we haven't run out of stuff to explore. So there's a lot of, there's a lot in the demo to let you understand. So what I discovered is that this character, in addition to not being damaged by monsters, they also have the ability to extend their protection to any characters that are beside them. So what we can do is we can maneuver these characters into place so that we can safely navigate through this little maze here. Okay, so we can move this guy over here, and then... Okay, so we're both safe, because these characters are next to each other. We'll just push them over here, and then... we can move them both into the exit tiles.
Please travel with us. We're trying to stop a really bad guy. If we catch the magistrate, the king will release me, and that will change my life. Again. But ignoring that, I'd capture this snake weasel just on principle. His trail of destruction is pretty long at this point.
Okay, so... it looks like what we need to do here is we need to push the monsters as well as the stone onto these orange pressure plates. After we activate all three of these pressure plates, then this force field, the yellow force field, should disappear. So maybe the first thing we're going to do is we're going to So this guy can push multiple objects at the same time. So he will push like this, so that the monster activates the pressure plate. Then we'll step off. And then we can do the same thing up here. Oh, but that kills off the monsters. Okay, so we can't have the monsters killing each other off, otherwise they won't be standing on the pressure plate. So let's undo that action. So we'll just move the monster like this, and then we'll push down from this angle. Then we'll have this guy go over here. Could also do like, okay. So we need to push the stone into place. So we'll move this guy over here, and then we'll move in this direction. And then we'll move this guy here, and then move the stone into place. Okay, and then... So that deactivates the force field. So from here we can move both of these characters over into the exit squares. So he will go here, and he will go here.
My meeting spot with my friend Tiff is up ahead. You'll like her.
I love having another girl on this trip. Don't get me wrong, the boys are great, but it's not the same.
Okay, so we've got different monsters in this map. These fire-breathing dragons on the right-hand side. If any creature enters their row or column where they're facing, they'll breathe fire on them. And we need to avoid that. So what's this other character? So this character doesn't get hurt by monsters. So they can block the fire shots. Okay, so we'll have this character. So this character pulls things after her. So we can have her pull the stones. Whoops. Pull the stones. Okay, and then we'll have this guy block. Whoops. Oh. Can't have that. Okay, and then we'll have this person block again. And then we'll have her pull the stone onto here. And Sack, hello, nice to see you here. Sack, you want to do exclamation point redeem, and then space, and then hack the planet. Okay, so he'll block here, she will exit, step onto the exit square, and then this person can step onto the exit square as well.
And that's when we decided to finally start the company. We're all good at moving things in our own ways, and we'd gained so much experience working at loading docks and so forth.
Okay, so I think what we need to do here is we need to have the green person, the thief, I guess we can call her, pull this other character, and because the two characters are beside each other, they don't get affected by the monsters.
Aelin's is incredibly strong. He says it's a trick, but the details are hard to talk about. Said he was taught by an older man, another soldier. Ooh, another disgraced soldier.
Okay, and... Uh-oh. What happened there? Oh, okay. I think I understand. So the green character pulled the monster, so we can't have that. We have to back up a bit then. So she'll pull this person over here, and then this person will move here, and then we can switch back to the green character.
Don't tell him I said disgraced. They have some official term for it. A neutral
Okay,
term.
and then we can keep on pulling over here.
Izzy's swap powers are amazing. Happen in some kind of accident? Great for moving heavy stuff, though, but not so great for getting close to people.
Okay, and then we can both exit.
I'm glad we had this time to talk.
Heroes to monsters. Okay, so we solved all of those levels. So on the overhead map here, the same rules apply. So we can't step next to any of these monsters, otherwise we get killed. So what levels are left? It looks like there are 3 sets of levels left. If the yellow stars are any indication. So one set over here, and then one at the upper right corner. So let's just try this set of puzzles here.
Oh, we're about to have some fun, aren't we?
Okay, so this pink force field only deactivates after all of the monsters are dead. So we need to find some way to have the monsters kill each other. So we can kill one monster like that. Kill another one like that. And, the problem is that we still have one monster left, the fire-breathing dragon. So we'll just go back in time. So we need to find some way to get onto the other side here without crossing the dragon's path. Oh, you know what we can do? We can go here, and then we can go here, and then we can push one more block, and then we can move around. So what we need to do now is we need to find some way to move this goblin guy, so this guy over here, into the square that is adjacent to the fire-breathing dragon so that they both kill each other off. So I think what we can do is we can push the guy around like this. And then go up down here, and then push the dragon up, and so the 2 monsters will get rid of each other. Okay, good. Great. Alright, and then over to the exit.
Dead monsters. Satisfying.
Let's think about this. Magistrate Reynard flees to the east, and about the time he gets here, it's overrun by monsters. Possibility, the first. It's a coincidence. Perhaps, but let's not jump to that. Possibility, the second. He caused this in some way. For what reason? To slow us down? That's a lot of chaos just for us. Possibility, the third. He came east because this was about to happen, and he knew? And he wants to stop it? Or take advantage in some way?
Okay, so this character, this blue wizard guy, he swaps positions with whatever object he faces. So if he's on the same row as this goblin guy and then he turns to face him to the left, he'll swap places with him. So I think what we want to do is we want to We want to get to the orange pressure plate over there to finish the level. But we also can't... We also can't move into the row with the fire-breathing dragon. Okay. So maybe... I think what we need to do is we need to move one of these goblins into this position. Uh-oh. Don't think I should have done that. Okay, so we need to deactivate the force field. We need to deactivate the force field, and we need to get onto the other side. Maybe I can bring this guy over here. Okay, so this is deactivated. Go up here. So I can't step down. If I step down, I get roasted by the dragon guy. Is there some way I could swap the position of the dragon? I don't think there is. I don't think there's a way we can do that. Oh wait. Hold on, let me go back to the beginning of the puzzle. So at the beginning of the puzzle, these guys all get roasted, but I can switch positions with the dragon here. Although that doesn't help me very much, because I can't really do anything from this position. If I swap again, then I get roasted. Okay. Well, it was a nice thought while it lasted. Let's go back to the beginning. Okay, so we can go here, here, here. And then now we need to figure out what the way forward is. So this guy can only swap if he has the capability. I can swap with this guy to turn on the force field. I think what we need to do is we need to move a bunch of these guys onto this path so that the dragon roasts them instead. So we'll swap places here, and then we'll move on to here, and then swap places. Whoops. That kills me. Okay. Then we can move another one of these guys onto the track. Like this. Okay, and then we want to put this guy on here. Okay, and then swap them here. Deactivate the force field. That guy dies. Swap places. That guy dies. And then we can go down and then solve the puzzle. Okay, great.
Thanks for helping me out, fella. And thank your friends for helping me think.
So use a club? Or a dirk?
Sword-bound doesn't mean just swords. It stops any kind of intent to attack.
Throw a rock? Punch him?
I could somewhat punch them. Not hard enough to do any good.
Okay, so what's this puzzle? So this puzzle... we need to deactivate the blue force field. So the goal is to get to the orange pressure plates. So both of our characters have to step on those plates. And where are we right now? So we can get her to pull this out. And then this guy can push the stone onto this pressure plate to deactivate the blue force field. The next thing we need to do is we need to get rid of one of these goblins. So we can see here that this goblin is guarding this path. We need to maneuver this dragon into a spot where it can kill one of the goblins, but not both of them. Zach, hey, hello, nice to see you here. Okay, so... oh, you know what we could do? Hold on. So this guy's gonna roast both of these goblins. That's fine, because... oh, maybe it's not fine. Maybe it's not fine. Because we need something to be standing on the pressure plate on the lower left corner to deactivate the yellow force field. So how are we going to do this? Why don't I have TTS? TTS is well, it's fun in some ways, but not so fun in other ways. Okay, I think... yeah, TTS, text-to-speech, I know. Text-to-speech can be a bit weird because you give random people control of your stream and what appears on it, and they might say some really weird stuff. So we'll go back. If we could... more engagement, more views, that's true, but I mean, I don't know if I'm ready to deal with the problems that TTS introduces. So people could start saying some really dumb things. Okay, we can push this guy into here, and then she can pull. Okay, that's the point, but I totally understand. Yeah, please understand. Okay, so maybe what we need to do is we need to pull the stone over here and then have him push in front, and then he can push over here. I think that she can pull multiple objects at the same time. No, she can only pull one object at once. Okay. So I guess we've got the same kind of problem. Although, wait. we can prevent the dragon from killing off both of the goblins by putting the stone in the way. So we'll put the stone in the way here, and then we'll push this. Have you been interested in physics, specifically metaphysics? I mean, I have been trying to get more into math to learn about cryptography, but I wouldn't say that I've been really interested in physics. But I mean, you know, what kind of physics are? Why you're talking about metaphysics? It really hasn't crossed my mind. So we want to kill off one of these goblins, and I think we can do it like this. So she can. She can't move. He can. Oh, you know what? Okay. She can pull the stone away. One of the goblins dies, and then he can push the stone back into the way. Okay, good. Whoops, I didn't want to do that. And then she can pull the dragon back, and then we can pull the stone into place. Okay, and then we can both exit. So he will go here, and she will go into the other place. And that's another level done.
See? When we work together, you don't need a club.
Not today, at least. Let's hope our luck holds.
Okay, Zach says free energy. I mean, it's an interesting idea. I mean, it can't be literally free, but I mean, magnets wear out after decades. Isn't that considered a long time? Are you talking about metaphysics and the ability for magnets to provide a long-term source of energy? I really don't know very much about that. Sorry to say. Okay, we've got some challenges over here. Oh. Okay, so we don't have access to this right now because there's the dragon blocking our path over here. We don't have access to any additional powers right now. Although, can we? Anyways, we'll just solve this this last set of problems we have access to over here.
Have you ever just clumsily dropped something? You had an easy grip. Everything is normal and fine. You were just turning to put some powders into a tincture. The tray clatters to the floor. Oh, it'll take hours to regrind those powders. How hard was it to just keep my fingers clasped? Did they open due to some kind of internal sedition? Did some part of me want to make a mess? Or have you ever, the candles flickering suggestively, the warmth of the air just so, well, you didn't have to use the word donkey, even if the sheen of the hair on her legs, in a nice way, I mean. It was like dropping the reagents, just like that.
Okay, so even if he's protected here, but when he swaps with the goblin, then he's no longer protected and he dies. Oh, it's SOS Master. Nice to see you here. Swap. I guess what we need to do is we need to put her up here. Okay, and then okay, having it over 30 Celsius inside is not beneficial to tracking things like the time. It's also very, very hot over here. I'm not too sure if it's 30 degrees right now, but it's pretty close. Over in Canada. Let me check the weather. It is currently 30. Oh, it is 30 degrees right now. 30 degrees where I am as well. But yeah, it's tough, especially if you don't have air conditioning in your home. Now, how are we gonna get these guys to... Maybe we should focus on moving this dragon guy. So the dragon guy over here only attacks on one plane, I guess. We'll move him over here, and sorry to everybody who finds the sound effects a bit annoying. Okay, so the fire-breathing dragon doesn't hurt him because he's beside the protector character. Same kind of source, different hemisphere, and no, it's not typical for air conditioning where you are. Yeah. Okay, so we need to get him to switch places with the dragon. So we need to eventually move the dragon beside the goblin, so that they both kill each other off, and then we can exit the level. So swap, 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 swap. Okay. And then swap down here. Okay, Sack says, I'd respectfully disagree. I mean, in the final model, the equation of everything, it requires free energy, but what is free energy is very misleading. The sun is a free energy source. It's going to be forever, and we can call it infinite free energy. I mean, the sun does have a finite amount of time that that is going to burn for, but it's in the order of hundreds of thousands of years. So we can essentially consider that infinite energy, or an infinite amount of time, but it's not really. But yeah, I mean, the sun is a good source of energy for sure. Okay, we can swap the dragon over one tile, okay. This is just a bit... It's a bit of a pain in the butt to do this, but eventually we can get these two monsters to face each other, and then that'll be the end of the level. Although, how do we do... Okay, and then we need to move... Okay, so the last thing we need to do is we need to move the dragon over by one. Maybe we can first move over here. And then over here. Okay. I mean, no worries. Nobody's trying to deliberately misunderstand each other over here. At least I hope. At least I don't. I hope not. Okay, let's see. I didn't read your question. Do you know about the Library of Babel? I mean, I've heard of the Tower of Babel. That's the biblical story where they divided all the people's like languages up. Is that the same thing? The story where everybody's languages got mixed up, or are you talking about something else? Okay, so this person effectively can't go anywhere. Swap over here, and then put her down here, and then swap the position of these monsters. And now we can get to the exit. Okay, done.
At times like those, I just wonder if there's some mind behind the mind. Something with goals askew to what we think we want. Something that creates misadventures, just to put us where it wants us.
Okay, so this level seems a bit straightforward, so we need the monsters to kill each other off. So because there's an even number of monsters... Wait, is this a different monster? No, it's not a different monster. Okay. Okay. Oh, okay, so it's a different story than the Tower of Babel. Okay, so the Library of Babel is a short story by Jorge Luis Borges, conceiving of a universe in the form of a vast library containing all possible 410-page books. Okay, there was something that made a USB stick like that recently. USB stick. It's something else. It's like an idea a mathematician had. There's even a site made about it, even a book. I found it and I recommend it. Huh. No, I haven't heard of that one. Library of Babel. Let me put it in another tab, and I can do some research on it later. Okay. So, let's see. I think what we need to do here is... find a way to swap. So put this guy over here, and put her over here. We can swap this guy over here. Oops. This is a weird position. Okay. Maybe I needed to shift everybody a bit before we started doing that. Okay. So we'll shift off one of these guys. Oops, that wasn't what I wanted to do. Maybe put her over here. Because we need to break this up a bit. Okay. So it is broken up a bit now, so... swap, and then put her over here, and then... swap. Okay, and then you can... Now, how do we put them beside each other? Put her up here. Nope. Oh, can't do that. Okay, so, man, I thought this was gonna. I thought this would be a lot easier when I first looked at this. So we need to get rid of these goblins 2 at a time. We need to put them beside each other with the swapping ability. Maybe put her over here, and then... This doesn't really work. Oh, it's closer. She goes here, and then he... Man, what's the best way to do this? Oh, jeez. Okay, so Zach says, it's a story about people getting stuck in afterlife and hell, angels, and zeroism. I'm not too sure what that is. They suffer until they find the life story written from one of the books across the library. Oh, so one of those we're inside of a simulation kind of things, or like something that is similar to that. So do we try to put both of these guys in a corner? So like this, and then he can move down. So he can move this guy out of the corner. Whoop, nope, can't move that guy out of the corner. Okay, it's a book, not a simulation, more like afterlife. So in the, can swap with her, that doesn't really do very much. So this is one of these situations where I'm just gonna stumble upon the answer, huh? Okay. Yeah, this is one of those levels where we just kind of stumble upon the answer. Okay, so those two monsters kill each other. We just need to find a way to do the same thing to these two guys. So we actually have more room to maneuver now. It's, Zionism. Angels and Zionism included. Brute force is a valid approach sometimes. So, I'm pretty sure I'm going to have to not brute force my way through this eventually. So this guy this guy's here. Okay, these guys are... Okay, so I think what we need to do is we need to put one of these monsters... Maybe this guy... We'll try to move him into... an adjacent space. So maybe something like this. Okay? Imagine being concise and being forced to find your life's book. Oh, that's what the story is about. Being concise. So now we need to... Oh, no, no, no. She has to stand right here. He has to... stand here. Oh, that's not it. Concise and conciseness. Oops, that wasn't it. The other way we could do this is we could put them on the same plane like this. And then put here, here, but then I can't move beside. XL, hello, nice to see you here. What is up? Okay. Yeah, but I can't switch positions like this. Oh, nope. Yeah. So let's go back. What happened? What happened? What was the position where we actually killed off the first pair? Let's go back. I mean, this is a lot of steps. Because we did it kind of like by accident, stumbling upon it. We should analyze it and then figure out what the exact configuration was. Okay. So here... we swap with her, Okay, we're protected. And then we swap across. So that the two monsters kill each other. So we should try to recreate the same circumstances. So he stands here. Okay, and then we teleport across. So she can move over. I think this guy needs to be a bit farther away. I mean, this is fine too. So he'll switch over here. And we want to put the goblin into this spot right here where the yellow person is. So how do we put him into this spot? Okay, then I suppose if we put this guy down here, that's fine too. So he will move. Here, okay, and then swap, and then the two, that took way too long, but we got there eventually. Okay, next level.
I was so careful for so long. I was careful. I was careful. I was careful. I was careful. Then,
So,
one day I woke up at 3 in the morning, full of energy, yearning to just do it all, thinking this has been enough careful, and it's time to just leap ahead. All this time being careful is making me old. I was working feverishly, half asleep, blearily. No surprise, a mistake. The stone was vibrating with power, and I dropped it, exploding. Tiny fragments of dark lith flying, piercing my body. And the I am as I am today.
Okay, so this time, what we need to do is we need to teleport the goblin into the middle here, so that these three goblins all kill each other at the same time. So Sack says conciseness. I think you're talking. I think what you want to say is you want to talk about consciousness, right? Consciousness, not conciseness. But let me know if that's what you want to be talking about, Sack. Okay, what are we doing? We want to move this goblin here into this position. So he can move here. Switch, switch. She can move here, and then he can move down here. Then swap like that, but I don't know. Huh. Okay, so I mean, it looks like it's not as easy as I thought it'd be. Maybe he can swap here. Swap here. Oh, you know what? I think we need to shift these two guys up one square. So shift these guys up one square, like. Okay, let's reset the level. Okay, so maybe here, and then move the other one over to this position. Okay, and then this. Then we need to okay, and then I keep on forgetting about the mandatory teleport. Okay, and then... Whoops. So we need to find a way to get this guy into the middle, into this position, to this row. Okay, we're probably going to have to come back to this next time because we've run out of time, but that's fine. Alright. Let's go ahead and get to the second part of today's stream. Okay, Zach is talking about Mr. Robot. What do you think? Did White Rose's machine work? I think that's why the original Elliot woke up. I mean, there's a lot of people talking about Mr. Robot and the whole, like, what was it? What is that? What would you call it? Like, would you call it like multiple dimensions or like parallel worlds or something like that? But let's go ahead and get out of this game. Okay, thank you very much for watching me play this puzzle game. And the next thing we're going to be doing is we're going to be doing some demos for easy exercises. So these easy exercises are from a platform called Hack the Web. Let me go ahead and set that up. So the overlays are here, topic 2 is here, and topic 3 is on deck. Okay, so what we have here is Hack the Web. So Hack the Web is a website where you can do a bunch of different challenges. They're mostly very easy exercises, but some of them can get pretty challenging if you solve enough of them. So we left off over here. So this one is the Click Me challenge, and it's kind of interesting. It talks about how we can get around certain web applications by giving them by changing variables. So let's get into this, and let me get the presentation file I have for this, and then we'll get started. So this is Hack the Web. The challenge is called Click Me. It's challenge number 53. Over here. Okay, let's get started. All right, everybody, this is a guided walkthrough for the Click Me challenge from the Hack the Web platform. Let's go ahead and read what we're supposed to be doing in this challenge. So the challenge is called Click Me, and the description says, what? I'm supposed to click a button 2,000 times for this task? What kind of crap is that? I hope you don't inflict this stupidity on yourself. Why don't you look on the page's source code and search for a hack or something similar, or use a program that does the clicks for you? Although it is a bit funny to just click. Okay, so what's going on here? We've got a button. Let me make this a little bit bigger. We've got a button. If we click on it, it progresses some sort of counter, and eventually we want to get to 2,000 clicks. But what we want to do is we want to find a way to bypass this or make it trivial in order to solve the challenge, because clicking 2,000 times seems a bit much. Okay, let's talk about it. So this is the Hack the Web challenge called Click Me, and in this challenge we're told to click a button 2,000 times or find some way to look into the web page's source code. So what's going on here? What we're doing is something called source code analysis. We can look at the web page's source code, and we notice that there are a couple of JavaScript variables being defined on the page. So we've got a variable called solution URL, which is a URL for something, and then we've got a variable called count, which is equal to 2,000. So immediately what we can do... Okay, so Dr. Wolf asks, do you have any good resources to learn assembly? Yeah, I've got a good resource to learn assembly. It's called, what is it called? It's called ASM Tutor, asmtutor.com. So this is specifically for x86 assembly for Linux, but x86 assembly for Linux, after you learn the one for Linux, learning the one for Windows isn't going to be super difficult. But this is what I recommend over here. So I also have like a list of different education resources for different things, including a bunch of programming ones over here. You may want to consider taking a look here. It's 90% the same between Linux and Windows. Yeah, there's a lot of similarities. So if you learn one, picking up the other shouldn't be too difficult. Anyways, let's go back to the challenge we were doing. Okay, so let's go ahead and take a look at the web page source. So we can right-click, then select View Page Source, and we'll notice those two variables that are being defined by the page over here, script. Yeah, so we got var solution URL hack.de chals clicker.en.png. So if we just directly go to this page, then we get the answer. So it says this is the answer here, and inside the PNG, the answer is crumbs. So this is the actual answer for the challenge, but let's just suppose that we didn't see that, and suppose that we wanted to solve this another way. So if we navigate to the link described in the solution URL variable, we immediately get the answer to the challenge. So, but if we want to learn another way to solve the challenge, we can take a look at the chal53.js file that is also being used by the web page. So if we look at the source code here, we look for stuff that is being run as JavaScript. We also see this other JavaScript file, chal53.js. If we click on that, we see the code that is actually running the application here. So we see var correct equals 0, var correct equals 0, and then when we click, it runs the check function. Let's make this a little bit bigger. So okay, so event listener click, when we click on the button, it runs the check function. The check function increments the correct variable over here, and if correct is greater than or equal to window count, then correct equals window.count, and then window.open solution URL replace. So what this does is it opens up a new window that shows the solution sends you to the solution URL. So what we need to do is we need to set the correct variable to a number that is equal to the count variable. And remember that the count variable was set to 2000 over here. Or is it 2000? So var count equals 2000. So what we need to do is we need to set correct to 2000 or more. So we can do that inside of the web page here by opening up the console. So we can use the F12 keyboard shortcut to open up the console. And we need to click on console over here, so the tab, and then we need to put in our JavaScript. So the JavaScript we're going to run is var correct equals 2000, because that's what we need to set the counter to get the answer. So we run the script, and then we try to click on the button one more time, and it redirects us over to the answer URL. We get the answer, it is crumbs. So to solve the challenge, we go down to the submission field, type in crumbs, and then click on go. And it says crumbs is correct. All right, everybody, that was a guided walkthrough for the Click Me Challenge from Hack the Web. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, that's just something I have to say for my YouTube videos that I need to slice these up all into. Anyways, we'll move on to the next challenge. So this one's done. And the next one is called... Hold on, let me go back. Okay, in chat, what are we talking about? That's a new one for me. Thanks, Shy Hat. No worries. There are more differences between processors than between OSs. Yeah, there are more differences between ASM, sorry, x86 assembly language and ARM assembly language. And what are some other popular chips? Okay, so the next challenge is Minecraft 3. Okay, let's go ahead and start this one. I need to get the, what is it called? The notes for this? Just a second. Walkthroughs, and then hack the web. And this is Minecraft 3. Here we go. Where's the Minecraft 3 PDF? Just a second. Oh, did I forget to? No. Here it is. Okay. All right, let's go ahead and start this challenge. So before we get started, let me go ahead and put on some new music for us to listen to, because it's a little bit boring if we are just listening to my voice. Well, I mean, maybe not boring, but I get a little bit self-conscious. Here's a little bit of music. Okay, so let's go ahead and get started. So this is the Minecraft 3 challenge from Hack the Web. So the description for the challenge says, "It's so dark here, could you turn on the light? Haha, I've got a little surprise. This redstone lamp has 7 switches and there's only one combination that makes the lamp light up. That should keep you busy for a while. I'll be back once you found the right combination." So what we have here is we've got a little web application with a bunch of switches. With a bunch of switches over here, what we want to do is we want to activate the lamp up here by flipping the switches. So down here, in the instructions, it says tap the switches and make the redstone lamp at the top center light up. And we've got a little tab here called Redstone Mini Guide. So before we get started, let's talk about what's going on. So this is Hack the Web Minecraft 3. In this challenge, we're asked to flip switches to make a Minecraft redstone lamp light up. So we need to flip the switches to make the Minecraft redstone lamp light up, and we've got the application over here. So what we're actually doing is, if we click on the Redstone Mini Guide tab, we learn that the switches at the bottom of the screen can be used as an AND gate. So AND gate means it's a type of logic gate that is used in computing. It says here, a redstone torch is on when the adjacent block is not powered. As soon as the block is powered, the torch turns off. With 3 torches and some blocks, you can build an AND gate. The middle torch only lights up when both inputs are on. With this knowledge, you can trace the circuit back step by step and figure out the correct switch combination. So what we need to do is we need to flip the 2 switches in the AND gate, and it activates the torch at the next layer up. So if we flip the 2 switches here, these torches go out, but the torch at the next layer up, it switches on. Okay, once we've activated all of the AND gates, the redstone lamp lights up and we can obtain the answer. So let's go ahead and do that. So back at the application here, can we make this bigger? Bigger. That's about as big as we can get it. Okay, so we see here, these two torches are lit up. What we need to do is we need to deactivate both of these torches to make the one at the next layer light up. This acts as a kind of like an AND gate, so we need to deactivate this and then deactivate this, which activates this one. Okay, and we'll do the same thing on these other layers here. So if we deactivate this one and this one, then this one will activate here, this one and this one. Okay, and if we activate this one here, then this one will activate here. So we do that. Okay, and that solves the puzzle, because these 2 AND gates are now activated, which lights up the redstone lamp. So if we click on Open Answer, then it says the answer is logic gate. So this was an example of us using logic gates, specifically the AND logic gate. So let's go ahead and solve the puzzle, or solve the challenge by going down here and typing in logic gate. Go. Logic gate is correct. All right, so let's go ahead and finish this up. All right, everybody, that was a guided walkthrough for the Minecraft 3 challenge from Hack the Web. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, let's go ahead and get going. Dr. Wolf, hello, nice to see you here. Oh, Risk V. Yeah, Risk V is the other, like, really popular chipset these days. Okay, so we'll go back and we'll do the next challenge. So the next challenge is the flipped challenge over here. Okay, let's set that up. So flipped is challenge number... which one? Flipped is challenge number 17. Okay, let me pull that up. Alright, let's get started. Alright everybody, this is a guided walkthrough for the Flipped Challenge from Hack the Web. Well, we can't actually read the description for the challenge because well, I mean, we could if we used like a mirror or something else to flip the text back over. But let's talk about what's going on in this challenge, and then we can solve it. Okay, so this is the Hack the Web Flipped Challenge. In this challenge, we're presented with flipped text. Okay, Dr. Wolf says, thank you. I was in Twitch and then I switched to YouTube. Better experience for me. Yeah, definitely use whichever platform is better for you. For some people it's going to be Twitch, for some people it's going to be YouTube. Okay, so what we're dealing with here is we're dealing with text formatting, and if we take a look at the web page's source code, we can see that the page text was flipped because of the HTTP style tags over here. So inside of the style tags, you can do transformations on the text, and in this case, we're doing scale -1, which means that the horizontal is going to be flipped over. So we can spot that by going over to the web page and then right-clicking and then selecting View Page Source. So this will let us take a look at the source for the web page, and if we go down, we'll notice the style tags over here. So the style tags enforce a certain style on the web page content. In this case, it flips the text over. But what we can see over here is we can see the text before it's flipped over. So it says, if you can read this text, you've already solved the challenge. Because the answer is vertical with a capital V, come on, grab a mirror, then you can read the text better. I mean, we could use a bunch of different ways to solve this challenge. In this case, we just take a look at the web page source, which is not flipped around. So the answer is vertical. We can just copy this. And in fact, let's go ahead and just talk about what's happening here. Okay, so on the web page, this is flipped, but we can submit the answer vertical, which is also flipped, and then press go, and then it says that vertical is correct and we've solved the challenge. Alright everybody, that was a guided walkthrough for the Flipped Challenge from Hack the Web. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so let's go ahead and move on to the next challenge. We've got like 2 more challenges to do. These are not super difficult challenges, but this is a very good website for introducing people to different tech concepts. Once again, the page is called Hack the Web, and it can be obtained over at this address. So if you've ever wanted to get into cybersecurity, but you think that you need a bit of a confidence booster, this is a very good website for introducing very basic level tech concepts in a very fun to learn way. So this is the Tedious Work Challenge. Okay, so this one, while I was solving this challenge, I learned about a fun little mathematical trick, and we'll talk about this in just a second. Okay, so let's go ahead. What is the... This is challenge number 8. Tedious work? Okay, let's do this. Okay. Alright everybody, this is a guided walkthrough for the Tedious Work Challenge from Hack the Web. So the challenge description says, in math class, our teacher tortured us with assignments. His specialty was long-chain calculations like this one. So it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay, I've always dutifully calculated them in order. Back then, I couldn't understand how some of my classmates managed to do it in their heads. Even today, I prefer to use a calculator in such cases, but no matter which method you use, the result of the calculation is your answer. So let's talk about what's going on here. So this is the Hack the Web Tedious Work Challenge, and in this challenge we're asked to do a little bit of math. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then add these numbers all together. So what we're doing is we're adding consecutive numbers. In the case that we have to add consecutive numbers, there's a trick that can make manual calculation much quicker. So the trick is this. We've got this list of numbers, so a set of numbers from 1 to 10, and we need to add them. Okay? If we add the first and last numbers in the set, and then multiply that number by the number of items in the set divided by 2, then we can get the correct answer. So in this case, there are 10 items. We add the first and the last items, so 1 plus 10, so that's 11, and then we multiply it by the number of items in the set divided by 2, which is 5. So it's 11 times 5, and we get the result, which is 55. So you might ask yourself, what happens if there is an odd number of items in the set? So in the case that there's an odd number of items in the set of consecutive numbers, we remove the number in the middle and we add it at the end. So if we've got a set of 9 numbers, so that's an odd number in the set, we do the same thing. We add 1 and 9, the first item and the last item. Then we multiply, well, we remove the number in the middle, which is 5, and then we count the number of pairs. So that means there are 8 items in the set. We divide it by 2, so that's 4. So that's 10 times 4, and then add 5, and we get the result of 45. Okay, so let's go ahead and try doing this ourselves. So in the case that we've got, I don't know, let's just do some a random set of numbers. So we got 5 plus 6 plus 7 plus 8 plus 9 plus 10. So that's 2, 4, 6. So we got these 6 numbers. So the first thing we would do in this case is we would take the first number and the last number and we would add them together. So it's 15. So it's 5 plus 5 plus 10. So the first number and the last number. And then we add the number of items in the set divided by 2. So that is 6 numbers divided by 2. So that would result in 3. So it is 15. Whoops. Oh, and I used the wrong symbol. Okay. So we multiply the first number and the last number by the number of items in the set divided by 2. So it is 15 times 3. 15 times 3 is 45. Okay, so that's 11, 21, yeah, 45. So this should be 45. We can check our math using Python. So over here we can do a Python shell, and then we can print the result of these numbers over here. So this is 45. So the other thing is, what happens if there's an odd number of items in the set? So in this case, let's do 6 plus 7 plus 8 plus 9 plus 10. So this is an odd number of items. So in this case, we do the same thing, but the first thing we need to do is we need to remove the number in the middle. So we remove the number 8, and then we set it aside to be added in at the end. So plus 8, and then we do first number plus last number, so 6 plus 10 times the number of items in the set minus the middle item divided by 2. So it's 1, 2, 3, 4 numbers. 4 divided by 2. And then the last thing we need to do is add 8. So in this case, it is 6 plus 10, 16, times 2. 4 divided by 2. 16 times 2 is 32, plus 8. So that's 40. So we can also check our math using Python. So go back here, and we'll print out the result of this. So this results in 40, so that is the correct answer. Of course, we've so the original question was 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So in this case, the answer is 55. And let's go ahead and, well, we'll do this manually one more time. Okay. So we have our 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like we did before, it is first number plus last number, and then we multiply that by the number of items in the set, which is 10, divided by 2, which is 5. So it is 11 times 10 divided by 2, 5, and the result is 55. So we will answer 55 to complete the challenge. Click on Go. And then 55 is correct. I mean, there are many different ways we can do this. We could also plug these into our calculator, but sometimes the calculator's not there, so it's nice to be able to have a way to figure this out. It's nice to have these little tricks. Alright everybody, that was a guided walkthrough for the Tedious Work Challenge from Hack the Web. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons in the video, and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, we've got one more challenge to do. And that's the birthday challenge. The birthday challenge is not super complicated, but we do need to, I am trying to complete all of the challenges eventually, so just bear that in mind. Okay, so birthday, I think it is challenge like number 27 or something, birthday. 77, okay. Okay, let's go ahead and start the challenge. Alright everybody, this is a guided walkthrough for the birthday challenge from Hack the Web. So the challenge description says, your task is to find the name of a person who has a birthday on June 23rd. The name you're looking for is hidden in the server's source code. Fortunately, the complete source code of Hack the Web is publicly available. In this folder, you'll find a relevant file named birthday.ejs. Good luck with your search. Okay, so what we're dealing with here is we're dealing with a little bit of source code analysis. We're also dealing with GitHub, which is a very popular repository. let's talk about that. Okay, so this is Hack the Web birthday challenge. In this challenge, we're told to look at the server's source code, and in a specific file, locate the name of a person whose birthday is June 23rd. Cool. ECME script modules. ECME script modules. Okay, so we're doing some source code analysis. The link in this challenge brings us to the Hack the Web GitHub repository, and we're instructed to look at the birthday.ejs file. So EJS. EJS, what is EJS? When I did a little bit of research, I found that EJS is actually an implementation of JavaScript that also lets you render HTML tags. But anyways, what we need to do is we need to go over to the link over here, and then we need to look inside of the birthday.ejs file over here. So birthday.ejs. So here, this is an exact copy of the page we're looking at over at Hack the Web. Only there's some extra stuff. So at the bottom of the page, we see a little comment over here, and it says the name of the person is Turing. So Turing is a very important person as far as computer technology is concerned. So if we go over to like Wikipedia and we look up this person, Alan Turing. So this person was an English computer scientist. Okay, so they were an English mathematician, computer scientist, logician, cryptanalyst, philosopher, and theoretical biologist. And this person's very influential in the field of computer science. So we see that their birthday is June 7th. No, their birthday is not June 7th. Their birthday is the 23rd of June. The 23rd of June, which we can see over here. Okay, so remember that on the page, where is it? Here, it says the name of the person is Turing, with a capital T. So if we go over to the birthday challenge, we can solve this by plugging in the name Turing, clicking on Go. April says, Turing's story is super sad. Yeah, I heard that Turing had had a tragic end. Okay, we'll click on Go, and that is the correct answer. Alright everybody, that was a guided walkthrough for the birthday challenge from Hack the Web. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video, and leave a comment underneath the video. But until next time, HackerFrogs out. SysOS says he had a tragic life, and it's as caused by the British government. I mean, let's refresh ourselves. So let's see. So Alan Turing's death. Okay, cyanide poisoning. So cyanide poisoning, when his body was discovered, an apple laid half-eaten beside his bed, although the apple was not tested for cyanide. It was speculated that it was by the means by which Turing had consumed a fatal dose. So he was persecuted for his sexuality because he was a They kicked him out because they thought that his sexuality would make him a security risk. It's kind of a grim story. He was basically the hero of World War II for breaking the Enigma code, and then he was treated very badly by his government. Yeah. Anyways, okay, so we got a bit of extra time until the next topic. So I think what we might do is we might go and solve some puzzles again, because April, the government forced forced that on him, that's really sad. Okay, so we're gonna continue from this puzzle. I finally solved the puzzle that we're gonna be doing over here, called the Easy as ABC puzzle. And we're just gonna be solving some of these puzzles for the next 25 minutes. You know how much I actually really like solving these puzzles, and let's restart. Let's talk about this. So let's go ahead and read the rules. Where's the intro? So at the Burrow's home, the welcome is all grumbles, puzzles, this, puzzles that. Wait, isn't that a puzzle right there? And what are the rules here? So this is an easy as ABC puzzle, also known as a letterraam in Dutch, meaning letter window or letter frame. Fill some cells with the letters PUZ to ensure that each column and row contains each letter exactly once. The letters outside the grid indicate the first letter seen from that direction. So we got P, which means that the first letter in this row is going to be P, coming from the left. But from the right, the first letter that we see in this row is going to be the Z letter. We also have up and down. So in this column, Z is the first letter that we see coming down this column. And then P is going to be the first letter that we see going up the column. So let's go ahead and make this as big as we can, and then solve the puzzle. So I've been having a lot of fun figuring out how to solve these logic puzzles. So we've got a P over here, which is P here, Z here, and if we've got both of these for both the column and the row, we can figure out what the cells are supposed to be pretty easily. Okay, so if we've got P as the first letter that appears in this row, and Z is the first one that appears in this row from this direction, we can assume that the letter U is going to be in the middle, because each one of these rows has to have P, U, and Z. So I think we can do P here, and Z over here, and then U in the middle over here. And from here we can start solving some of these other rows and some of these other columns. So we know that P is the first letter, which means that these have to be blank. So from here, P is the first letter that appears in this column going up, which means that these have to be blank, which means that the Z has to appear here and the U has to appear here. And then we can keep on going. If you want to solve the same puzzle that we're doing, you can find the puzzle over here. So from here we've got so Z is the first letter we see in this. Z is the first one here, Z is the first one here. I think that means that this has to be a Z right here, because Z has to be the first one coming down. And remember that these rows can only ever contain one of the same letter. So we got the Z's going down here. SysOS says you've already done this one. Yeah, I had to sit and do this over and over again to try to understand the logic. Okay, so this one has to be blank. This one has to be blank. And P has to appear in one of these two spots. So I'm guessing, well, we should do as little guessing as possible. We should be using some logic to solve these. So this has to be blank. And because Z appears here in this column, this has to be U. and this has to be P, because the P appears first from this direction. So Z has to appear first in this direction in this row. Row 1 is now defined. Row 1 is now defined. Row 1 is here. So this is U, and this is P. So P, U, Z, like this, because they've got, well, we have to include all these. And so P, this is fulfilled. So the P in this row has to be here, because it doesn't fit anywhere else. Okay, and from there, well, the last P has to be here, because we've got these other P's, they all kind of like appear in a row. Although, yeah, so the P has to be here, or it could be here. So this has to have a Z. No, it can't be here. It has to be here, because this would put the P in the same column. So this has to be the P, and this... So the Z has to be... Okay, so this has to be blank. U, P... So there's two more... Oh, no, this has to have a... So there's a P, there has to be a U, and there has to be a Z. So U has to show up first here, and that means there's going to be a Z here, and a Z here. And that's it. That's it. Okay, great. Wow. I'm still not used to doing these puzzles, but I had to go out of my way to teach myself how to do this. It's all about learning new rules and new systems. That's what we hackers do, solved by using logic. Okay, so the next puzzle is over here. So this is puzzle number 20. Solved using logic. Yeah, it's a beautiful thing to see. Okay, so a frightened book borrower slumps to the ground, hands over their eye. As a sheet of paper floats to the ground, a puzzle. So this is another more difficult puzzle. We've got 3 out of 5 difficulty. Okay, so what does it say here? So shade exactly 2 cells within each outlined 2x2 window, such that all shaded cells form a connected group. The connected group of shaded cells cannot touch itself diagonally, and there must be no 2x2 blocks of shaded or unshaded cells. The padlock cells are already shaded for you, so those are part of your solution. Keep in mind that each 2x2 outlined window must have exactly 2 shaded cells. All shaded cells must form one connected group, so these things all have to be connected together. The shaded group of cells must not meet at only a diagonal. In other words, no 2x2 checkerboard patterns. So we can't have any of these squares, any of these shaded squares, they can't be diagonally across from each other. Know the rules before you break them. Yeah, I mean, most of hacking is just understanding the system. You can't really exploit the system. You're best able to exploit a system that you understand, is what we're trying to say. There cannot be any 2x2 shaded regions. There cannot be any 2x2 shaded regions. Oh, okay. So they can't be shaded regions that are next to each other. There also cannot be any 2x2 unshaded regions. So we can't have 4 squares that are not shaded. The padlock cells are already shaded for you and form part of your solution. Okay, so let's go ahead and do this. So 2 by 2. Okay, let's make this as big as possible before we start solving it. Alright, and we just need to make sure that each one of these squares has a 2 by 2 shaded square. Is there some sort of logical system that'll take us through this? Or do we just do some experimentation? Maybe like this? Maybe like... I have no idea. Okay, so... These all have to connect together, though. We're only allowed 2, so... Maybe stretch like this? Because we need to connect these. We can only have, each one of these 2 by 2 shaded squares can only have 2. And they need to be connected, so we can't do this. I'm assuming we would do something like, well, we can't have any diagonals. So something like that. But then there's a diagonal over here. So, got it solved in 2 minutes and 24 seconds. It's going to take me much longer than 2 minutes and 24 seconds for me. So we can do this. It all has to be one contiguous pattern. One, two, 1, 2, 1, 2. Okay, this is not a race, and your streaming is not remotely fair. No, I mean, I'm pretty sure that even if I wasn't streaming, you know, and it's not a race, it's not a race, it's just, we're trying to understand the rules of the game, because that's what we hackers do. We try to understand the rules of the game. Okay, let me take a look at some hints, because you know, SysOS Master, can you give me a little hint on how we're supposed to bridge this gap right here? Because we need to connect this over here to the rest of the group. That gap form the top. That gap forms the top. So they all need to be connected, don't they? Each 2 by 2 outlined window must have exactly 2 shaded cells. All the shaded cells must form one connected group. One connected group. What is the site? Can you share? Yeah, I can certainly share this. Here's the link. So maybe we can do it like this. But we also need to connect over... This is not what they want. Is the music loud for others or is it just me? Okay, it is a bit loud. Let me turn it down a bit, because this is a pretty loud song in general. Okay, let me start getting some hints. Okay, the rule about the shaded group not touching itself diagonally is very important. If a window already has one cell shaded, where must the other shaded cell not go? Mark it with an X. Okay, so we can mark with X's where it can't go. So it can't go here, and for this one, it can't go here. And for this one, it can't go here. Okay, you're joining the puzzle. Thank you for for participating. Okay, and for this single one, it can't be here. So mark those with an X. We marked all the ones that we can't do with an X. The second window down on the right, here, has two given shaded cells. These need to find some way to connect to the rest. Which way can they go? So they can go up. Maybe they can do something like this. But we also need to connect them to this one, to this cell. So we also can't have 4 unshaded cells. We can go up here, and then over here. I mean, the problem with this is that we've got this diagonal, and we can't have any... The shaded cell group of cells must not meet only at a diagonal. In other words, no 2x2 checkerboard patterns. So we can't do this checkerboard pattern. Now you made a diagonal. Yeah. So in order to not make a diagonal, we'd have to either leave this alone, like this, or go down like that. Nope, that's... Okay, and then... So maybe like this, maybe like that, and maybe like that. That's another diagonal. Did we make another diagonal? So it has to go, this has to go somewhere. So maybe, yeah, that's a diagonal. So we can't do that. That's another diagonal. So we'd have to, well, we can't do that. Okay, let's get another hint. What about the third window down on the right? The third window down on the right. So on the right, third window down. If you keep the can't touch diagonally rule in mind, there should only be one valid cell to shade. Okay, so this creates a diagonal, so we can't put it here, so we can only put it here. Diagonal in the second middle too? The second middle. Oh yeah, there is a diagonal here. I used all 3 hints. I'm sure I'm going to use all of the hints. Okay, so we can't create a diagonal here either, so we need to go like that for this one. And if we don't want it to create a diagonal here, we have to go like this. maybe like that. So these are all connected. So maybe we go here. Oh, no. We can't create any 4x4. We can't create any 4x4 unshaded blocks. So this has to be like that in order to not create the 4x4 unshaded block. And then like this. But then we need to connect this one over here. Oh wow, I kind of stumbled into it. Only 2 shaded per... Okay, so... So this is what it looks like, huh? So we go on across, and we can just leave this kind of like dangling over here. We just need to make sure that there are no diagonals. Alright, let's move on to the next puzzle. So, puzzle number 21. We got 4 minutes to solve this one. I wonder if that's enough time. Good job, I like this puzzle. Yeah, it is fun to discover new types of games. Still grumpy, now grateful, the borrower shares their book, The Town's Chronicle. It contains only a brief mention of the solvers, but a curious symbol appears beside it. This is a nonogram? This is a nonogram, okay. So let's read about this. So this is a nonogram, a very popular puzzle type commonly known as Picross, which is a Nintendo trademark. 2 puzzle makers, Nanashita and Tetsuo Nishio, both independently invented nonograms in 1987, completely coincidentally. Follow the number clues around the edges, and Shaden sets in a cell to reveal a message. Okay, it didn't say it could only connect in one place. Yeah, sometimes you need clarification. Oh, this is supposed to be an easy puzzle, huh? Okay. Keep in mind that a number next to a row or column indicates how many shaded consecutive cells there are in that row or column. Shaded cells form from a single number. Clue must not be separated from each other, so they need to be contiguous. When a row or column has more than one number clue, it means that there are multiple groups of those shaded cells. These groups appear in the same order as the clues. So we got, if we have 1, 1, or if 2, 1, and 2, that means that has to be 2 shaded cells, and then a space, and then a 1, and then 2. Okay, the shaded cells can be in any position in a row or column as long as the group size and order matches the hint. Multiple groups of shaded cells must not be connected to each other. Multiple groups of shaded cells must not be connected to each other, which means that they have to have at least one space between. You can right-click a cell or tap it twice on mobile to mark it. Use these marks to remind you which cells shouldn't be shaded. Thinky Dailies 21 Chronicle solved in... It's a nice picture for our purpose. Yeah. Is this as big as we can get it? I think this is the biggest we can get this one. Okay. So... 1, 1, 1. I think we can solve this one first. So it's 2 and then 1 and then 2. So if we go downwards, we do 2 here, and then we do 2 here, and we do 1 here. So there's only one pattern that fits. We have 1, 1, 1. This could be a few different ones. We have 5 over here. So 1, 2, 3, 4, 5, which means that this has to be all shaded in. Yeah, this thing is 5 cells wide. So it's a 5 by 1, 2, 3, 4, 5, 6, 7. So it's 5 by 7. We need to keep this in mind when we're solving here. So this is 2 and 2. So for this row, there's only one pattern that matches. So 2 and then skip 1 and then 2. This is also 5, which means that this is completely filled in. Okay, and then from here, we've got 4 and then 2. We've already got the 2 here, which means the 4 has to be up here. And then we've got 4, 4, just 4. So we got 3 here already, so this 4 has to be here. And then here we've got 3. And we have 4 down here as well. So 4 on this column. So if we have 3 here already, we just need to fill in 1 more. Okay, and this has 3. So because we've got 1 here and 1 here, the only pattern that matches is 3 here. And that's it. That's an unlocked lock. Sack, thank you. Thank you for letting me know about that. Okay, so how much time do we... Well, we don't have any more time. But let's take a sneak peek at the next puzzle. Just so that we see what we're dealing with next. And then we'll move on to the next part of today's stream. Here's the link. So what kind of puzzle is this? Oh, it's a line puzzle. So this is a simple path puzzle, also known as a Hamiltonian path puzzle. Trace a path to the from the entrance to the exit, passing through every space along the way. I mean, can we solve this super quick? We'll save this for next time. We'll save this for next time. Or, I mean, if we've got some extra time at the end of today's HackerFrogs After School, then we can solve this as well. Okay, so topic 2 is done. Topic 3 is here. And topic 4 is on deck. Okay, so this is HackerFrogs After School session number 2 for network service hacking. And let's see. So we got our session notes over here. I'll just pass everybody the session notes. These are all the links we're going to be using for today's class. And given the heat, don't forget to drink. Thank you, thank you. I just need to put some time on the clock. So we got 60 minutes, and I'll take my opportunity to have a drink the next time an ad shows up on Twitch. Just let me know if I don't catch it. Okay, so we're going to be using this particular Try Hack Me room to learn about network services. Thank you for redeeming the Budweiser frogs, April. Thank you. Okay, so let's go ahead and get started. So this is HackerFrogs After School, network hacking session number 2. So this is the second session for network hacking. Let's go over the concepts we covered in the previous session. I'm drinking on the job. You know, some people do drunk streams. I don't know if I could do that. I don't think it would be a very entertaining watch for everybody. We learned about a few different concepts in the previous class. We learned about ping sweeping. Ping sweeping is the act of sending ping packets to each address on a network range for the purpose of determining which IP addresses are online. So this isn't something we typically do in our network service hacking challenges, but it is a very useful thing to know as part of network diagnostics in general, trying to figure out which machines you have access to. We also learned about the ping command, which is a very common way that we determine connectivity between two networking devices. So if your device can get ping packets back from another device on the network, that means you have connectivity. So we also learned about looking up your networking info with the IP and ifconfig commands, sorry. So we can, we'll also need to get our own networking info, which we can do with the IP command. So the IP command syntax to get the information for our networking setup is IP space A. And the last thing we learned in the previous session was enumerating open ports with Nmap. So Nmap is a very common networking security tool that can be used to determine which networking ports and services are open on remote servers. So I say it's a security tool, but it's not necessarily used for security. You can also use it to just determine which networking ports are open and which services are available on a remote server. Cypher says, interesting fact, don't block me? What? Unclothedness is actually fine on YouTube as long as you do nothing weird. In most cases, not being clothed, I mean, there has to be a specific purpose for showing unclothed stuff, right? Nmap is a generic purpose tool. Yeah, you can, well, I mean, a lot of people use it for security, but it's not necessarily used just for security. Okay, so in today's session, we're going to be talking about common networking services. So the networking services are going to be the FTP service, the SMB service, and the Telnet service. So these are pretty common services that you'll see when you're dealing with networking security challenges. So we want to be able to interact with all these on a regular user kind of basis. So we'll that's why we're learning about them. Okay, so we're going to be accessing a TryHackMe room to learn about common networking services. So this is the room over here, tryhackme.com/room/learn cyber in 25 days. So this is one of those Advent type rooms that they feature on TryHackMe for the month of December. But it doesn't need to be December for us to use them. So let's go ahead and get those links. Where did I put that thing? Okay, here's the link. FTP, Telnet, what is this, the 1980s? Well, Telnet especially is not commonly seen anymore, but FTP you do see every once in a while, especially like on internal networks, and SMB is very, very commonly seen on Windows machines. Okay, so the TryHackMe room is over here. I used it at LAN parties. Telnet was used in the 2000s. You used it at LAN parties. I mean, it's a lot easier to get people to log in using Telnet as opposed to SSH, because, well, I mean, pros and cons for everything. I'm not logged in. Let me log in first. So to use these rooms on TryHackMe, you need to be logged in. Yeah, it has 0 security. So Telnet has 0 security. That's why people use SSH these days. I'll touch on that in just a bit. Okay, so 25 days of cybersecurity. What you need to do after you arrive on this page is you need to join the room, because you can only interact with systems if you're joined in TryHackMe. So click on Join Room. User is already in the room. So, okay. All right. Let me reload this page. Okay, so the first part of this session is in task 11 on this web page. So after you arrive at the room, you want to click into task 11 here. So task 1, we're looking at task number 11 for this part. Okay, so there's 2 things we need to do in task number 11. So click into it. You want to click on Start Lab Machine, so that green button over there, and you want to click on Start Attack Box. So to be as inclusive as possible, we're going to be using the attack box to interact with the machines over here. I'm not assuming that everybody has access to a Linux machine. That's why we're using the machine that's provided by TryHackMe. Okay, Cypher says, I started to go off of TryHackMe because it's not as good as it was before. I mean, I agree that there's a lot of people seeing some bad things over at TryHackMe, but it's still a very good resource for people trying to, especially beginners, who might not necessarily have the equipment for learning about cybersecurity. Okay, so we're just going to wait for this to start up. It's going to take about a minute or two, but in the meantime, we'll read up on what we're supposed to be learning in this task. So in this task, we're going to be learning about the FTP service. FTP stands for File Transfer Protocol, and it's a very common networking service which allows users to upload and download files. So the service name is called FTP, File Transfer Protocol. The common port that you find for FTP is TCP port number 21, which is the control port, and TCP port number 20, which is the data transfer port. The main purpose of this particular service is for file storage and transfer. SysOS says, I feel like THM is getting more flack than it deserves, especially for its AI use. I mean, I'd say that some people have some legitimate gripes with TryHackMe, but there's no real good free alternative to a lot of the stuff that's offered over at TryHackMe. Okay, so accessing FTP, we can access the FTP service through the FTP client program, which can sometimes accept anonymous login. So let's see if our TryHackMe room is completed. Its startup process. Not yet. Okay. So we'll go back and read a little bit more. So some common FTP commands that we're going to be using to interact with the service over here is these ones over here. So ls, cd, get, put, and quit. So if you don't know any other commands when you use FTP, you should know these ones over here. So ls is going to get the directory contents. cd is going to change the directory to another directory. Dapril says, I'm not happy with the AI training, but I don't hate them. It's still a wonderful resource. They've done a lot of work over the years. Yeah, I mean, there's nothing... Still move past them, though. Yeah, I understand. For beginners especially, there's a lot of really great content that they can get for free from TryHackMe. So the cd command lets you change directories. You can use the get command to download files. You can use the put command to upload files, and you can use the quit command to exit the program. Okay, let's check back in. Okay, so now that the attack box is finished initializing. So after this is done, you can click into this terminal window here and hit enter to dismiss the window. We're going to be interacting with the FTP server via our terminal, which means you need to click on one of the terminal shortcuts to open up the terminal. So we can click on this one up here, and that's going to get us access to our terminal. So the first thing we need to do is we need to connect to the service. Actually, the first thing we could do is we could run an mmap scan to figure out if we can actually communicate with this machine. So there are two IP addresses at the corner of the screen here, and the top one is the one for the target machine. So the target machine is 10.146.140.0. Oh no. No. That's our IP address. So the one we want to access is 10.146.139.109. 134.109. So we can try pinging the machine with the ping command we talked about in the last class. Let's make this a little bit bigger. Okay. Not ping first? Yeah, we're pinging first. Ping space C2. We'll send 2 ping packets to 10.146.134.109. So we get this IP address from over here. So the bottom IP address with the black icon, with the black box icon. So when we send that command, we send these bytes over to the IP address. We get a response back. 2 packets transmitted, 2 received, 0% packet loss. This means that we've got access, we got network connectivity to this machine. So another thing we could do is we could run an nmap scan on the machine to figure out which ports it has open. So nmap -p -vv for very verbose, and then T4 for very fast but not too fast, and SV to get the versioning information for whatever service that we find. So finally, we provide the IP address. Okay, and then run the command. And so the reason why we give the specific flags in nmap is so that we can get output from the command before the command is finished scanning. Okay, so we see that there's port 21 and port 22 open on this server. So port 21 is the FTP service, and port 22 is the SSH service. Okay, so with all that said and done, we can actually connect to the FTP service on this server by running this command. So FTP space and then the IP address. So connected to this, welcome to the TBFC FTP server. So the name here, sometimes FTP accepts anonymous login. So it's asking for a name. We type in anonymous, make sure to spell that correctly. And then it says login successful. Remote system is Unix, use binary mode to transfer files. So from now on, we're actually inside of FTP. So we can see that the prompt here changes to FTP. We can run the ls command, and then we can see what's inside of this FTP file share. Anonymous. I mean, sometimes you need to spell it with a capital A. In this case, we don't. Okay, so from here, what we want to do is we want to see what's inside of the FTP file share. And we see here that we've got a few different directories. So backup, elf workshops, human resources, and public. We can start maneuvering ourselves into the different directories. So cd backups, and then ls to see what's in here. So there's nothing in here. We can also do ls-la to see if there are any hidden files. There are no hidden files in here. Okay, to back out of this directory, we do cd ... which sends us to the next directory up. We can also run the pwd command to see which directory we're in. So most of these are very Linux-like commands for FTP. So from here we can move into the elf workshops directory, cd elf_workshops, and then take a look at what's in here. There's nothing in here as well. That's fine. We can cd ... to back out. So I'm using a keyboard shortcut to clear the screen and go back up to the top. It's Control-L. You can try this out yourself, Control and then L on the terminal. And we're just going to move into the next one, human resources. cd human resources. Remember that most of the time you can hit the tab key on your keyboard to autocomplete the names of files. Okay, there is also nothing here. So this is actually, we actually see that there's nothing in this directory inside of this ls command. So the ls command shows us that there's nothing in, there's 0 bytes inside of each one of these directories. So that's a good way to know that we shouldn't be looking inside of them. So the last directory is the public directory. So let's go ahead and enter the directory, cd public, and then there's two things in here. So there's backup.sh and there's shoppinglist.txt. If we wanted to download these, we can just type in get and then the name of the file. So get backup.sh to download the file to our local machine, and then get shoppinglists.txt to download that text file. So from here, we've gotten all of the files that we can from the system, and we can exit. So to exit from FTP, just type in the word exit and hit enter. Okay, so now you can see from the prompt here that we're not in the FTP system anymore. And we've downloaded these two files, shoppinglist.txt and backup.sh. So we can read the files, the Polar Express movie, shoppinglist.txt, and we can also read the backup.sh file. Okay? So this is a bash script file. and that's fine. So the last thing we're going to do is we're going to demonstrate how to upload files to the FTP server. So the first thing we want to do is we just want to create a file. And we're going to do that using the echo command. So we're going to echo out like and subscribe to HackerFrogs.txt. So to everybody who who wants to do the same command that we're doing over here, I'll just paste this into the chat. Okay? And when we run the command, we'll see that we've created a file called HackerFrogs.txt. If we read it using the cat command, its contents are like and subscribe. What we want to do is we want to upload this to the FTP server. So we run the same FTP command we did before. So FTP and then the IP address. And then from here, we need to log in again. So we'll put in our name as anonymous. Okay, and we have write access to all of these directories apparently. So let's move into backups. So cd backups, and then we're going to upload our file. So put is going to upload files, and when we use put, the default location from which to upload is the directory that we were in before we ran the FTP command. So put HackerFrogs.txt, and then could not create file. Huh. So apparently we don't have write access. That's right. We only have write access to the public directory. So let's back out. And then let's enter the public directory. So cd public. Okay, and then let's try uploading that file. Don't we need to do it in public? We do need to do it in public. Okay, so we can put HackerFrogs.txt. No control connection for command. Directory send OK. So did it actually upload? Not connected. Oh, we got logged out at some point. Let's try connecting again. Yeah, I guess we got timed out. Did the machine reset? The machine might have reset. Let me try reloading this page. Yeah, no route to host. Okay, we've got some problems here. We'll try pinging the machine again, just to make sure we have connectivity. 10.146.134.109. And it looks like the machine is offline. So it says 2 errors, 100% packet loss. So we don't have connectivity to the machine. Let me see if I can start the machine up again. We'll try reloading the page. Okay, so So this machine was started up in task number 11. So it says lab machine task 11 is on, but for some reason we weren't able to ping the machine. We'll try pinging the machine again. Okay, Sack says you don't use Reddit. You don't use Reddit, and you also don't use Discord. Oh, I mean, where else could you I mean, if you all want to talk about tech topics in the YouTube chat, it's fine, as long as you're adding each other. So I know not to read out those messages. It's fine. Restart the box. It's foobar. Okay, I guess we need to restart this box. So we'll just go to the box, and then we'll terminate this box. So go here, we will terminate it, and then we'll restart the box. So let's see, lab machine task 11, start lab machine, and it's going to take a minute to start up. But yeah, SysOS and SAC 3000. If you wanted to talk about other tech topics, that's fine. You can talk in the YouTube chat. Okay, so we're just gonna wait for the machine to start up again, and then we'll try pinging it again. Thornless Roses, hello, nice to see you here. Oh, SAC 3000, do you use Twitch? Because you might be able to send like private messages to SysOS Master if he's okay with it. You can send private messages inside of Twitch as well. Okay, and we should get the IP address again in just a second. So the IP address is going to be 10.146.165.112, and we can we do have connectivity to that. Oh, you also don't use Twitch, SAC 3000. Okay, it's kind of let's connect with SSH, of course. Alright, so from here, we're just going to reconnect to FTP. So FTP, this same IP address here. We log in as anonymous, and then we're going to move into the public directory. So cd public, and then we're going to try uploading our hackerfrogs.txt file. So put space hackerfrogs.txt, and it says transfer complete. Okay, so just to double check that it actually arrived, we see here that we've successfully uploaded hackerfrogs.txt to the FTP server. Okay, from here we're just going to get out, and that's your basic operation on FTP servers. So if you have any questions about FTP, let us know. Otherwise, we'll move on to the next common network service. So the next one is SMB. So SMB is the next common network service, and it's the same room inside of Try Hack Me, but it's task number 12 instead of task number 11. So let's go ahead and set that up. So over at Try Hack Me, so we will go up to task 11, and we'll shut down this machine. So click on here, and then we'll terminate target machine task 11. And then we'll navigate over to task number 12. So click on task 12. Okay, and then start the inside of task 12, click on Start Lab Machine. So in about a minute, the machine will be up, and then we can try to access it. So while it's loading up, we'll talk about what the SMB protocol is, or what the SMB service is. So SMB service, this stands for Server Message Block. So the service name is called SMB, Server Message Block. The common port used by SMB is TCP port 445 and TCP port 139. And its main purpose is for file sharing and for printer sharing. So this is something that you'll very commonly see on Windows servers. And the SMB service is a file and printer sharing service that is most commonly associated with the Windows OS. So accessing SMB. So on Linux, we can access SMB shares through the SMB client program. So SMB client is a program that we use to access SMB through Linux. So there's also some enumeration we can do with a specific program called enum for Linux, and we can use this to enumerate the SMB environment. When we connect to SMB, we have to specify a share to connect to, and we can use another program, enum for Linux, to do that. This will get us a lot of information about the SMB server. But So in the meantime, we can talk about some common SMB commands. So the commands that we use inside of SMB are actually very similar to the ones that we use for FTP. We use the dir command instead of the ls command because SMB was originally developed for Windows, Windows servers, and Windows servers usually use dir to get their directory contents. So the cd command is the same as, well, it's the same across all of those systems. So the get command is going to download a file, the put command is going to upload a file, and the exit command is going to exit the program. Okay, and let's go back and see if the machine is started up. Alright, so we've got a new IP address. What we can do one more time is we can run the nmap command. Nmap, we're going to try to figure out what ports and services are available. We're going to run it T4 for very fast but not too fast. And we're going to run it to get the versioning information for the particular services that we find. So the last thing is the IP address, 10.146.146.241. Okay, so use the IP address that you have over here for the black box icon. So from here, it lets us know that there are a number of open ports on the system. So there's port 139, port 22, and there's port 445. So 139 and 445 are both associated with the SMB protocol. So it says port 22 SSH, port 139 NetBIOS, and port 445 NetBIOS. So when they say NetBIOS, they basically mean SMB. And what we can do is we can also interact with the we can do some enumeration on the system using a very common Linux tool called enum for Linux. So just type in enum for Linux -a and then the IP address. Oh, it's supposed to be capital A. So enum for Linux -A. Okay, so we actually get a lot of information really quickly, and we don't need to pay attention to everything here. What we do need to pay attention to from the enum for Linux command is that there are a number of different file shares that we can access. And where are our file shares? Okay, so there's the IPC file share, the TBFCHR file share, the TBFC IT file share, and the TBFC Santa file share. So we don't necessarily have access to all of these file shares, and I think there's only one that we actually have access to. But we'll talk about how to. Okay, hey Shaihat, do you know what enum for Linux NG adds? Enum for Linux NG, I hear that enum for Linux NG is the more up-to-date version of enum for Linux. I'm not exactly what additional capabilities it adds, but I do think that it will get you more information. What that information is, I'm not completely sure about. Okay, so let's go ahead and access the file share. So what we want to do is we want to run SMB client to access a specific file share. So SMB client, and then / the IP address, and then another /, and then the name of the file share that you want to access. So let's go ahead and do that. So SMB client / the IP address. So 10.146.146.241, and then another /, and then the name of the file share. I think the file share we want to access is tbfc-santa. And then they're going to ask us for a password. So we're going to be accessing this anonymously. So we're just going to hit enter for the password. Okay. And from here, we're actually inside of SMB now. Okay, Thornless Roses says, have you considered using env variables so you don't have to type in the IP every time? I mean, you can use env variables to sub out the IP address, but in this case, we should get used to using the IP address, especially if we're doing this for the first time. Anyways, okay, so we're in the SMB server. We type dir to get the directory list. So what we have, we've got Jingle Tunes, which is a directory, and then we've got a note from McSkitty over here. What we want to do is we want to download these files. So to download what that's going to be, just get and then the name of the file. So get note from McSkitty.txt to download the file. So we'll also check out the Jingle Tunes directory here. So cd Jingle Tunes. And there's nothing in here. There's nothing in this directory. Okay. We can back out of the directory by doing cd ... And then we can exit from SMB by giving the exit command. So after that, we see that our prompt has changed, which means that we're no longer connected to SMB. We can read the note from McSkitty file that we downloaded with the cat command. Hi Santa, I decided to put all of your favorite jingles onto the share, allowing you to access it from anywhere you like. Regards, McSkitty. Okay, so the next thing we can do is we can upload files. Well, assuming that we've got upload privileges from our what is it called? From our anonymous access. So what we want to do is we want to upload our HackerFrogs.txt file again. So let's go ahead and run SMB client to connect to the share. Okay, they ask for the password, just hit enter. And then I wonder if we can upload directly to the root directory here. So to get your present working directory name, you do pwd. Current directory is tbfc santa. Great. We'll try uploading the file, so put hackerfrogs.txt, and then we see that hackerfrogs.txt is in the file share. Okay, so we've successfully uploaded a file, and from here we can just exit. Okay, and the last thing we want to do is we want to... No, I think that's it. I think that's all we need to do. So we got about 20 more minutes for this class, and we're going to be accessing one more service. So let's go ahead and stop the service for task number 12. So click up here, and then click on the terminate button. And then we're going to go, I think it's task number 13 next, right? So we've done FTP, we've done SMB. The last one we're going to be doing is Telnet, which is task number 15. We'll be playing the puzzle game. This one is looking easy too. Telnet? Which puzzle game are we talking about? Oh, you mean the puzzle game we were doing before? You mean this one? The Thinky Games puzzle? I mean, if we've got a little bit of extra time, then sure. Okay, so we're going to go over to task number 15. So click on task 15, and then start this up. So click on the green Start Lab Machine button. Okay, so that's going to take a minute to start up. And in the meantime, we'll just talk about what Telnet is. So Telnet stands for Telecommunications Network. The service name for this service is Telnet Service. The common port that you'll usually find it on is TCP port 23, and its main purpose is for remote login. So a long time ago, before the SSH program was a thing, people used a little program called Telnet for remote access. So it's a service that allows remote terminal login, and it's the predecessor to the SSH service. It's a means to hook an open web port to a TTY/shell. Yeah, so you can run all of your commands through that particular service. So to access Telnet, you just need to type in Telnet and then space, and then the IP address of the server that you want to log into. So of course this is going to be a little bit different if Telnet is not operating on its default port, but most of the time when you're accessing Telnet, you just need to run Telnet space and the IP address. Something, hello. I hope you're doing well and fine. Thank you very much, something. Nice to see you here on YouTube. So typical Telnet access provides terminal access to the server, and you can use terminal commands associated with the server's OS. So if you use Telnet to access a Linux server, then you're using Linux commands. If you're using Telnet to access a Windows server, using Windows commands. And, well, I mean, it's the same kind of thing with SSH. If you SSH into a Linux server, you have to use Linux commands. And if you SSH into a Windows server, you have to use Windows commands. Okay, so let's go ahead and try that out. So over at TryHackMe, we see that the server is up and running. It's got this IP address over here in the corner. And we'll try ping the machine, because we need our practice. It's 10.146.169.66. Okay, and because we're able to successfully ping the machine with 0 packet loss, that means we have connectivity to the machine. So the next thing we want to do is we want to run an nmap command to make sure that the ports are open. So we run nmap -p- and then the IP address 146.169.66. So the command we're running looks like this. I'll just copy it into chat. Nmap is it's a pretty powerful program, and there's a lot of different things you can do with it. What you want to do is you want to find a workflow with Nmap so that it does what you want it to do. We actually discovered a bunch of open ports on this machine. So there's port 22, which is SSH. There's 23, which is Telnet. 111, which is RPC bind. Not exactly sure what that is. And then we've got another service on port 39915. And I'm not too sure what that might be either. Okay, so let's go ahead and log into the service. So it's Telnet. Whoops. Let's get the IP address. So the IP address is this. We're just going to sub out our nmap command for Telnet. Okay, so it's just Telnet space and the IP address. And we see a little message. So it says, "Hi Santa. We knew you were coming. We decided to make it easy to drop off presents, so we created an account for you. Username Santa, password Claus Christmas. We left you cookies and milk. Christmas login." So we can log in as the Santa user and Claus Christmas. Just to make sure that we're not misspelling this, we're just going to copy paste this. So copy and then paste. Then hit enter. Okay, and we're now logged in. So if we take a look here, we've got 2 files in this file share. So christmas.sh and then cookiesandmilk.txt. So because Telnet by default basically lets you do remote login, all of our Linux commands are going to work. And what we need to do is we can navigate all over the file system. So we see that this is a typical Linux file system. We've got all of our typical directories. So boot dev, etc opt, and let's see, also the home directory. So if we move in here, we see that Santa has a home directory. That's great. Move into the directory, and then we've got Christmas.sh and cookiesandmilk.txt. So the thing about this is that I'm not too sure if we can just, well, we can read these files. Cat Christmas.sh, and it looks like some sort of script. Okay, and we could probably run the script here because telnet is lets us run any command that we could normally do on the terminal. But before we do that, let's take a look at the cookiesandmilk.txt file. No tab autocomplete here. Okay, so let's see. How do you manage to do a shift and do your study and go live and teach this stuff? I mean, this is kind of my job. I've got other stuff that I'm responsible for. But, I mean, I'm trying to teach everybody about different cybersecurity topics on Twitch and on YouTube. Okay, too bad, Santa. I, the Grinch, got here before you did. I helped myself to some of the goodies here, and you can still enjoy some half-eaten cookies and this leftover milk. Why don't you try and refill it yourself? Yours truly, the Grinch. Great. Okay, so what we're going to do is we're going to try running the Christmas.sh script. I think before we do that, we need to make the script execute. Oh, it is executable. Okay, so we're just going to ./Christmas.sh to run the script. Hey, here we go. That's a fun little a little animated Christmas tree. Okay, something asks, do you have any resources to help me reach and build a network device? Reach, help me, or teach me how to build a network device? By build, I mean the installation of NOS, network operating systems from online models. I mean, I don't I don't think so. I mean, I do a little bit of technical support every once in a while, but it's not really something I've done myself. Something. Some of the other people in the chat might be able to help you. Anyways, we can exit out of this program by doing Control-C, and that gets you out. Okay, so we've covered three different services that you can access. Well, you can access some of these are more common services than others. I guess we'll talk about a little overview of these three services right now. So the FTP service, the SMB service, and the Telnet service. So the FTP service is, let's make this a bit bigger. It's commonly seen on internal networks. It's very rare to see this exposed from the internet because FTP is not it's not a secure service. So FTP runs without encryption, which means that everyone who sees the network packets between FTP servers and clients will see every command and potentially passwords in clear text. Yeah, TryHackMe usually has some very good documentation for all of its stuff. In fact, if you go over to this particular room over here, Learn Cyber in 25 Days, there's a lot of information inside of each one of these tasks. It's a very good resource. But yeah, so that's the FTP service. Of course, this is a file sharing service. Sometimes FTP file shares are visible from the web, or visible from web apps, and this is very dangerous. So if you can upload files that are accessible from the web, then you could potentially upload a malicious script file, which could be used for RCE, or remote command execution. Okay, so that is the FTP service. The SMB service is very commonly seen in Windows environments, because this is the service that is used for Windows network file sharing and printer sharing. So the SMB service is also what else do we say about the SMB service? There is interoperability. What is the word we should use here? Interoperability between Windows and Linux machines using SMB. The Linux implementation of SMB is called Samba. SMB is the least supported network file sharing solution, but the only one that's guaranteed to work with Windows? I guess so. And the last thing, so the SMB service, I wonder if SMB is encrypted. I don't think, nothing really indicates that SMB is encrypted. Let me look that up real quick. Is SMB network traffic encrypted? Not really, it uses hashes. Okay, good friend AI tells us SMB encrypted traffic is not encrypted by default, while modern SMB versions include native end-to-end encryption to protect data in transit. This feature must be manually enabled and enforced by administrators. Okay, so SMB might be encrypted, but it has to be the modern version of SMB. Okay, and the last thing we'll talk about is the Telnet service. So the Telnet service was replaced, well, is largely replaced by the SSH service. The reason why it was replaced is because Telnet is insecure. Why is it insecure? It's because Telnet traffic is unencrypted. So because all Telnet traffic is unencrypted, anyone intercepting the traffic, may see full commands passwords, other secrets in clear text. Okay, so Telnet is sometimes, but rarely, seen on internal environments. But it really should be retired. Okay, so we've got a little bit of time left. Let's go ahead and wrap up this session. We might have a bit of time for a puzzle or two before we move on to our last topic. Let's review the network hacking concepts we learned in this workshop. So, a bunch of different services. The FTP service. The FTP service is a common networking service which allows users to upload and download files. The SMB service is a file and printer sharing service that is most commonly associated with the Windows OS. And the Telnet service is a service that allows remote terminal login and is the predecessor to the SSH service. Thank you very much for subscribing on YouTube, Yuzo the creator. Thank you. Thank you very much. Okay, in the next HackerFrogs After School Network Hacking Workshop, we'll learn about how to perform web app enumeration with a number of different tools. So, you might ask, why are we doing web app enumeration with different tools if this is a networking course? It's because web apps are the most common networking service, or one of the most common networking services. Anyways, we'll be doing that next time, and next time is on Friday. So we're going to be doing our next class on Friday. Please stay tuned for that. Anyways, we'll move on to, well, we've got like 5 minutes left. Let's do another puzzle. Okay, so what we need to do in this puzzle is we just need to create a line from the entrance to the exit that covers every single square in this maze. So I think what we need to do is we need to go this way first, because we need to start here and we need to exit over here. So we can, whoops, we go through here and then up and around. Yeah, this is, it doesn't seem super complicated. Yeah, there we go. Okay, we'll move on to the next puzzle. Alright, here's the link. Something says, where can I find your schedule? Yeah, you have a new subscriber. Oh, you talking about Yuzo the creator? Anyways, okay. So the schedule, yeah. So the schedule you can find it over at the Reddit or on the Discord. So we've got a Reddit over here. We also have a Discord. Okay, let's solve the next puzzle. As one might expect, the lock maker's door is locked, and they're certainly known for making unusual locks. So what's the puzzle here? Okay, so this is... what is this? So this is an unusual variant of the Star Battle. Unlike your typical Star Battle puzzle, this one isn't divided in regions. Place exactly one star in each row and column. Each row and column gets one star, ensuring that there are no two stars that are next to each other, including diagonally. Okay, keep in mind that. Place exactly one star in each row and column, sure. There can only be one star in each row. There can only be one star in each column, okay? Stars cannot be next to each other vertically, horizontally, or diagonally. You can click a cell or tap it twice to mark it. These X marks to remind you where stars cannot go. Okay, so... So this is all one big region. How do we figure out where we're supposed to put our first star? Okay, let's make this nice and big before we start. We need to find a constrained row and or column. So this row, there are not very many choices. This row, there are not very many choices either. So we should probably start from here. Maybe we can put a star. Maybe we can put a star here, or wait. That would also be. So here's. So this row has to have. Each row has to have a star. Each column also has to have a star. This row can only have one of two positions for the stars, so that's why I decided to start here. This column also has only two choices for the star. Let's suppose, I'm not too sure how we can decide where to start. Let's start reading some hints. Okay, so it says that there's an important technique to learn here. When a star must be in one of two positions, both of those positions might have shared cells that they would block. Without knowing exactly which position the star goes in, you can put an X mark in those shared cells. Where can we apply the pattern? Without knowing exactly which position the stars go in, you can put an X mark in those shared cells. So we're talking about... Oh, there's three. So this column right here only has two positions. We need to put an X, we need to put a star in one of these. Both of those positions might have shared cells that they would block. Shared cells that they would block. So the thing about putting our star here is that this blocks the least number. This gives us the most places to put additional stars. So maybe we should start here. And then so this row and this column has a star. I guess the next one to try is another row and column that might have... So this is also... This row here also only has two. So it's either here or here. If we put this here, this blocks off the rest of this column and the rest of this row. I guess we probably want to go with the option that blocks off the least number. So this blocks off the least number of possible cells in this column. Not that that's necessarily the correct way to do it. And I guess that means... we can go to this row. So this row here, the second one from the bottom, it's got 1, 2, 3, 4 possible places. Jay Soberback, hello, nice to see you here. How's it going? We're gonna be moving on to our last topic in just a second. I'm just trying to see if I can solve this puzzle over here. It's a star battle style puzzle. I don't know if anybody is familiar with these. This one's supposed to be fairly difficult, apparently. Okay, let's get another hint. The top row only has 2 possible spaces for a star. Rather than guess which space it goes in, which cells can you... What? The top row only has 2 possible spaces for a star. Okay, so this is the top row. Rather than guess which space it goes in, which cells can you mark with an X? Rather than guess which space it goes in, which cells can you mark with an X? So we mark these with an X because they could go in. Trying to predict a future event without a base, right? I think so. Okay, so one of these is going to have the star, and that means that these other cells are going to be blocked off. Once you've done that, what about row 2 now? Can you use a similar technique to place an X mark? So the second row, assuming that these are not available, has to be one of these 2 cells over here. So if one of these 2 has a star, that means that these are all going to be blocked off. Okay, and once you've placed that X mark, you should finally be able to place your first couple of stars. Perhaps now there's another place that we can apply the technique from the earlier to place another X. Okay, so if this row can only have 2 possibilities, this one or this one, that means these ones are all blocked off. That means that this has to be a star, because there's only one spot for this particular row. So if this is definitely one of the spaces, then we can continue from here. So that means that this is probably a star. Okay, next hint. So after you have 3 stars, look for any spaces where if you were to place a star, it would completely block another row or column from having a star. It should all start to fall together at this point. Yeah, I mean, I don't really see it. Okay, let's restart. So there's an important technique to learn here. When a star must be in one of two positions, both of those positions might have shared cells that they would block. When a star must be in one of two positions, so this position or this position, they might have shared cells that they would block. Without knowing exactly which position the star goes in, you can still put an X mark in those shared cells. Where can we apply this pattern? So there's only a possibility of 2 stars in this row, the first row. The top row only has 2 possible spaces for a star. Rather than guess which space it goes in, which cells can you mark with an X? The top row only has 2 possible spaces for the star. So we don't know for sure which one of these 2 it is. Once you've done that, what about row 2? So row 2 has these possible for a star, which means that if it's in either of these 2 positions, then these are blocked off. Oh, and now we've got these 2 possible spaces for a star. Okay, my LLM is just trying to understand the ones which are cubes and which ones are locked. I mean, I'm pretty sure that if you give this to an LLM, it should be able to solve it. So now we have 2 possibilities here. So if these 2 are here, then it locks off these ones. And now if these 2 are here, it locks off all these, which means that there's a star here. So from here, we need to figure out which ones are actually valid. We have one for 1, 2, 3, 4, 5. We actually have something here. So for all these columns, all these rows, and all these columns, we need 1 star in each one of them. They can't share any spaces. So this one is... it's likely not this. This star is here. It should all start to fall into place. Star, star, well, there are 2 stars here. They can't share. Look at this. 1 star in each row. 1 star in each column. Okay, there's the other rule as well. So the other rule is that the stars can't be diagonal. They can't be next to each other diagonally. So we'd have to get rid of this. We have to put it here. We'd have to get rid of this. And we need to get rid of this. Oh, you know what? Because the stars can't be next to each other diagonally, it really does help to narrow down the possibilities. So if there's a star here, we know that they can't be next to each other diagonally, right? And then there only leaves 1 possibility here for a star. which would block off these and block off these. And then, so if we suppose that this is for here, and this is for here, then this row, there are very few possibilities for this row. So the star should be here, and this star should be here. And then for the next row, because we've got these blocked off, we could go... It's going to be either this one or this one. And it's not going to be that one. But which one is it? So if we suppose that it is this one, then we can put a star in one of these places. And that means that this star has to go here. So one of these stars is going to go here? No. Huh. Something tells me that I don't have the right placement. One. There's no space for a star in this column here. So we need to find. Let's just suppose that this is the star for this column. These placement restrictions are kind of tough. Okay, let's restart one more time. If there's a star here or here, that means all of these are restricted. That leaves one possibility for this row. And if that's the case, then these are blocked off. But that can't be the case because we need something for this row. So it should be like this, which means we can put probably a star here, and then we move downwards. So put a star here, and then for this row, there are no... Yeah, so it can't be here. It has to be something like this. So here, 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 then no, but it can't. Like that. And then for the next row, here. And then one more. This bottom Okay. I kind of lucked into that one. Anyways, try it out yourself. This is the link. And we're going to move on to the last portion of today's stream. Okay, so we're doing topic number 4 now. And topic number 4 is this over here. So it's a challenge over at Hack Smarter. And what we're going to be doing is we're going to be doing some cloud security stuff. So data secrets, it's a medium level challenge in the AWS category. So we'll enroll in this. This is a free module. So anybody could anybody could do this. You don't necessarily have to pay money. So Hack Smarter is a platform that is created by a security tester named Tyler Ramsby. And let's go ahead and get started. So what we're going to do is we're going to launch the Data Secrets virtual machine, which is going to start up the cloud environment. And the other thing we should do is we should probably read up about what's going on in the challenge. So how to launch the AWS scenario, you should probably know about this. Launch the machine and connect to the VPN. Go to the machine IP port 8000. Whitelist the IP. Oh, okay. So I'm going to have to do this off screen at some point because I don't want to show my IP address on stream because that would be a bad thing. Okay, let's see. Select data secrets and create scenario. You'll receive an access key and a secret. This is your starting port. Your output will be different. Okay, sure. All right, so before we do this, let's read about what we're supposed to be doing in this challenge. No IP sharing. We try not to do IP sharing anyways. The objective scope for this challenge is the Hack Smarter Red team started offering AWS pen testing. The client's primary concern is whether an attacker is able to gain access to their secrets manager. Your task is to begin with starting credentials and see if you're able to perform lateral movement and privilege escalation to gain access to their AWS secrets manager. This is where the final flag is located. Okay, and then they've got an advertisement for their course. All right, so we'll start. Let's go ahead and we started the machine. And what we need to do is we need to connect via the VPN. So let's go ahead and click on this tab. Click on Systems. And there's going to be a VPN configuration button over here. So if you don't see these tabs, go ahead and start making the interface smaller. That'll reveal some other elements of the web page. So this VPN key is called Challenge Lab Data S OVPN. Sure. Okay. So we can connect to the environment. I'll call this tab Platform Access. Okay, we've got an ad running on Twitch right now, so when ads run on Twitch, this is the first one I've done in the first 4 hours or so. We'll put on some birds. Okay, and we'll be back in about 60 seconds. I just need to take a water break, but enjoy the birds and the music. Oh, sorry, I was muted, everybody. Sorry about that. Okay, so let's see. So I'm going to go ahead and turn off my sharing so that I don't share with everybody my IP address. Let's go ahead and do that. Okay, so what I'm doing right now is I'm starting up the scenario, and that'll give me access to my AWS credentials. I'll copy those, and then I'll start sharing my screen back again. It's taking a bit of time. So it says starting creation for this scenario. It will take several minutes. Okay, so I'll just how should I do this? I'll check back in a couple minutes. But in the meantime, we can talk about what we're going to be doing on this box in this exercise. Okay, so let's see. Okay, so this is in AWS security challenge. The goal is to enumerate the cloud environment, to obtain secrets from the AWS deployment. We start with low-level privileges, or a low-level privileged account with a low-level. We start with a low-level account. We will attempt to escalate our privileges. We'll probably be escalating our privileges through some sort of security misconfiguration. Okay, and yeah, that's essentially what we're doing here. So the first thing we need to do is obtain our low priv account keys, and then start enumerating. Got a milkshake. I'm ready for cloud stuff. Awesome, awesome. Hope you're having. Hope that is a tasty milkshake. Okay, so I'm just going to I'm going to check back in on my cloud stuff to make sure that it's not leaking any of my secrets. Okay, so I think I'm just going to copy this over to a file, and then I'll show everybody what's going on. Yeah, share everything, of course. Okay, so I'll share. what's going on here. Okay, so using default profile, default from config.yaml, and we've got start user access key and then start user secret key. So we've got an access key, we've got a secret key. We can start our enumeration from here using the AWS CLI tools. So let's see. Typically what we would run first is... Let me rename this tab. We'll call this our AWS CLI. So AWS configure. So it'll ask us for an access key ID, which I copied, pasted in. Okay, and then it's going to ask for a secret access key, which is over here. So secret access key. Okay, so default region name. So in most cases, you're going to get different access depending on the region name. We don't know what region is being used for this particular scenario. So the easiest thing for us to do right now is just to use US East 1, which is the default one. Default output format, none. This just sets what kind of format your queries are going to come back in. Usually it's JSON format. Okay, so from here we can run a few different commands. So AWS STS get caller identity. So we're the CG start user. So CG start user, this is our username on the system. And what we need to do is we need to figure out what access this user has. So I've been trying to write up a little guide over here on AWS testing, more so for my references, so that I can remember how to do this stuff. You can find it over here in HackerFrogs After School. Okay, so setup, starting enumeration. I think we've done the setup already, right? Yeah, so this is setting up AWS CLI. So if you've never done this before, you need to set up the AWS CLI tools. So AWS configure. Yeah, okay, and then we'll move on to starting enumeration. So starting enumeration, the first thing you want to do is you want to get your user info. AWS STS get caller identity, and then you might see something like this. So the output lets us know that our username is this thing. Sometimes you need to use your username for certain actions. So the first thing we're going to do is we're just going to try to enumerate some S3 buckets. So AWS S3 API list buckets to see if we can get access to any of these files. Well, I don't know what the specific word is for these buckets. I guess we can just call them buckets. Okay, so yeah, so we're not allowed to do the list all my buckets action, so that's a no-go. We can also do AWS S3 LS to get some information about these buckets. Okay, so looks like that doesn't go. So SNS, this is another service on AWS that we could enumerate. So we're just going to try all of these different commands and see if we've got permission to do any of these things. Because if you don't do the test, you never know. So list topics, list subscriptions. I don't think we've got any of this. Most of the time, if an AWS environment is locked down, let's see, what are buckets actually used for? Just cloud storage or like server storage? A lot of web applications use S3 buckets for assets, for their website. So instead of hosting their own assets, they just host it on an S3 bucket. So enumerating API gateways. This is another thing that we could give a shot. Okay, can't do that. So the other thing is IAM. So IAM is Identity and Access Management. This is the authorization system of AWS. It controls what we can do on what AWS resources and under what conditions. So we can try to list out users, list out roles. Okay, can't do that. And looks like our user can't do very much because we're not getting any output from any of this stuff. Okay, this command lets you list out the members of a specific group. I don't think we're going to be able to do that. So this command lets you know what permissions you have, general policies. So our username, we want to figure out what our user can do. So just a second, I need to figure out CG start user something something. Okay, so this is our name. Let me just copy this. Okay, we don't have any attached user policies, or at least we can't enumerate these. So this So the other thing we could do is we could use our tool over here, our Paku tool. And Paku is a tool that can be used to enumerate, brute force enumeration of permissions. So what are we allowed to do? So we would typically run Paku inside of a virtualized environment. And the tool is, you can find it over here at this repository. So let me go ahead and create a little tab for that. Okay, and let's create a little virtual environment for Python here. Python venv, and then do some activate the virtual environment. Okay, and now we can start installing our tools. So I think the command we want to use is pip install -u paku, and that'll install the tool. Okay, that's gonna, if it's, this could take a while because it's downloading a lot of dependencies and stuff as well. So I'm just gonna leave this running in the background. So after this is done, we just run Paku, and then we can check our account permissions by running this particular module. So I am brute force permissions. So in the meantime, we can go back to the Hack Smarter. Where is it? Let me get rid of some of these tabs I'm not using. Okay, so we did all this. So we just need to keep in mind that we have to, the goal for this scenario is to gain access to the secrets manager inside of the AWS environment. I'm not too sure. I think I might have interacted with the AWS Secrets Manager once or twice, but it's not something that I'm super familiar with. In the meantime, we can do a little bit more like manual testing. Let me close out some of these tabs I'm not using first. Again, that's Paku. So DynamoDB, that's AWS's database tool. We got SNS, we got API gateways, S3 bucket stuff. Enumerating bucket contents without credentials. Enumerating bucket ACL access control list. Yeah, we don't even know if we can access any of these buckets, or if there are any buckets. A pig gateway. All right, still downloading stuff. Okay, we weren't given any indication as to buckets, so we're just gonna hang tight. So the only thing we need to do in this challenge is submit the final flag. No hand-holding here. I suppose if we get super stuck, we can start looking at some walkthroughs to get ourselves unstuck. There's no shame in looking at walkthroughs if you're absolutely stuck. The important thing is that you learn something from the exercise. But I'm gonna try to brute force my permissions first to figure out what we can actually do in this environment. But then again, I need to wait for the tool to install first. So the Paku tool is an open source AWS exploitation framework designed for offensive security testing against cloud environments. So we're doing the pip3 installation. Okay, the first time Paku is launched, you will be prompted to start and name a new session. These sessions are used to store AWS key pairs. So after we start up Paku, we're going to feed it the key pairs that we have. Modules require an AWS key, which grant you minimal access to the AWS environment and is comprised of the access key ID and the secret access key. Okay. So when we're inside of the Paku tool, we're going to be taking a look at different modules. I only know how to run one of these modules, but of course there's a bunch of different ones. We might be learning a lot more about how to run the Paku tool a bit later. Okay, it's done. Right, so we can run Paku now. Okay, so we're going to do a new session where we'd like to name this new session. So this is data secrets. And we need to set keys. So import, let's see. Okay, no key set. I guess we need to give it some keys. Where did I put that thing? So the access key is here. Now, do we want to import keys right now? Oh, this is importing keys from a credential file. That wasn't the command. We want to... We want to set keys, set underscore keys. Set keys. Okay, and then key alias. Okay, so the key alias, let's just do data secrets starting. Okay, we will give the key ID and then the secret access key over here. Session token, we don't have a session token. Okay, key saved to database. Alright, so we're here, and let's go ahead and run our brute force enumeration. So run IAM brute force permissions, because we don't really know what our permissions are on this account. Okay, this might take a while to run. We'll leave it on running in the background. I wonder if there's an option to output to a file, because this creates a lot of output. So output to file? No. Okay. To file? I mean, if it, I'll give it a try. Ignifer, there's a lot of special pleading. Special pleading? I mean, are you talking about the automatic messages or something else, Ignifer? Because it's running all these checks right here. I suppose what we really want to pay attention to is the stuff that it outputs at the end. This is just brute forcing all of our permissions right now. Most of the time it tells us that we don't have permissions to do these things. I'll just leave this running for a little bit and wait for it to come back. You can T it too. Can we run that from the Paku command line? Running Paku from the CLI, help session name list modules. Okay. Exec the module. But April, have you used a lot of Paku before? Let us know. Okay, there's a bunch of plugin modules. Framework development goals. Improve interactive formatting. Attack playbooks for easier use of complex module execution chains. Oh, bash stuff. Okay. There's also a wiki for Paku, which is nice. I'm assuming that if you do a lot of AWS testing, that you work with Paku a lot. Okay, so I guess we found something. So services supported EC2, S3, and logs, unsupported, unknown 32. 32 allow permissions found. So what we're going to do is we're just going to copy the output after all of this stuff here, and we're just going to put it in a file. Okay. It's a lot of output. Okay, and then we'll put this in our research tab. Starting user perms. Save it out. That's a lot of perms. Well, I mean, most of these perms are allowed permissions. EC2, I mean, I don't think we care a lot about these EC2 ones. I'm not too sure. So S3, get object torrent head bucket. Get object torrent head bucket. Wait, why is this over and over again? Logs, get log record, denied permissions, everything else. Denied permissions, all this stuff. Okay, I am brute force permissions module summary. Services, EC2, S3, and logs, unsupported, we don't know, unknown. 32 allow permissions found. 1,120 deny permissions found. 32 unknown permissions found. Okay, we'll go back up to the top. So these are our allowed permissions. These are our EC2 stuff. And then denied permissions is everything else. Which one of these is going to... So get object torrent and head bucket. I don't know what either of these commands do, but we can try them out. Okay. So get object, found invalid choice, get object torrent. So, S3, get object torrent, head bucket. Do I need to add head bucket to the command? AWS S3 help. So this said something about a, what was it? Get object torrent. Maybe it's easier for me to just search online. AWS S3 get object torrent. Okay. Get object torrent API operation retrieves a torrent file for a specific object stored in S3 Amazon bucket, allowing you to distribute files using BitTorrent. BitTorrent. I mean, just because we can run this doesn't necessarily mean that we should be running it. I'm not sure. Because most of the stuff we see here is denied. Agent 57, hello, nice to see you here. It must be... That's awesome, but probably not the root. Probably not the root, I agree. But how are you doing, Agent 57? Nice to see you here. Let's give you a special Hack the Planet redeem just for you.
Hack the planet! Hack the planet! Shut up again!
AWS is 3 bucket, head bucket, bucket, bucket. I mean, we don't know what buckets exist here, though. So head bucket. We also have logs. We can get log record. So would you run it like AWS logs get log record like this? Maybe you meant get log record. So is it like star? Thanks, dude. I'm okay. How are you? Oh, yeah, we're just trying to figure out how to do cloud hacking stuff here. Read the help for the command. Okay, let's see. Logs. So is there an actual logs command? It told us that we have this permission, but I'm not too sure which command we want to write. No, AWS command help. Okay, AWS get log record. AWS logs get log record command retrieves all the fields and values of a single complete log event from Amazon CloudWatch logs. So it should be, I mean, it should be this. AWS logs get log record. Do we need to give additional parameters for this? The following arguments are required log record pointer. So when we run, so unique string pointer corresponds to the log event record. Okay, so do we need to optional parameters? Run a query and get the pointer, execute a logs inside AWS logs start query. AWS log start query, I mean, I'm pretty sure we don't have permissions to do this. If we do start query, it's going to give us an error message because I don't think we've got that permission. No, you need start time, end time, or query string. Log record pointer. Get pointer. So how do we get these pointer values? To get the log record pointer for the AWS CLI get log record command, you must extract the value from the pointer field returned. Okay, so I mean, I'm pretty sure we can't get these. All right, let's get ourselves unstuck because I'm not too sure where we're supposed to be going with this. Taking a look at the permissions we have here, are we supposed to run some of these EC2 commands? Or are we supposed to do something else? Okay, so let's take a look at one of these write-ups to get ourselves unstuck. All right, summary setup. So we got the configuration. Okay, we've done this. We verified the access. We do the recon. So the focus of the scenario is solely on AWS. We have credentials. We're trying to extend our privileges to the AWS Secrets Manager where the final flag is hidden. Okay, the scenario is generous, and with the credentials available, we only have limited access. We list the running EC2 instances. Okay, so I haven't done very much with EC2, so this is a good opportunity to learn more about using the enumerating EC2s. You were right on. And yeah, Rukmani Tumani, hello, nice to see you here. And hope you're having a good day. So describe instances. EC2 describe instances. Let's do that. Okay, we got a lot of stuff here. So, because there's a lot of stuff, we're just going to redirect the output of the command into ec2 describe.txt so that we can look through it later. Mustafa, hello, nice to see you here. Okay. Let's take a look at what's here. So, what are we looking for? We're looking for potential credentials and or buckets and or anything else. I suppose the other thing that we could look for is we could look for like IP addresses. No, like URLs. ec2.internal. We might have access to this. I'm not sure. CloudGoat. Yeah, I mean CloudGoat is the name of the name of the platform that they use for cloud security testing stuff. Okay, we've got a private IP address and a public IP address. Public IP address. Can we try to access these? Or, I mean, the first thing we would try to do is we'd try to ping them. Nope, doesn't look like we can ping this. We also have the private IP address. Pretty sure we can't access this either. Nope. Okay. We've got a bunch of IP addresses. We've got some tags. So it's stack, CloudGoat, scenario template. We're keeping a lookout for potential user account credentials. Yeah, if we look through this and we don't see anything, I guess we'll keep on reading the walkthrough. I haven't seen anything interesting. Are you watching through the live stream, or are you doing this yourself? Because you could be doing this yourself right now if you really wanted to. Because the stuff that we're talking about, it's a free scenario from HackSmarter here. Okay. Okay, more public IP addresses. The other thing we could do is we could just try to access these things from the web browser. Because sometimes you can access stuff from the web browser that you can't access from ping, because some people have their pings turned off for their servers. This is a lot of data to look through. You really need to know what you're looking for. Otherwise, you can spend a lot of time just looking at stuff that doesn't go anywhere. This might be one of those scenarios where I need to treat this as a learning exercise. Grep secret? Yeah, maybe. Maybe. Okay, so we need to grep that. Key or password? Okay, can't find. User EC2. Okay. Well, we find a lot of EC2 stuff. Grep. Oh, yeah. We need to make sure that we're grepping with insensitive mode. Look for those passwords. Look for those keys. Okay. So it looks like key is a pretty common thing. And the last thing we'll look for is secret. No, no secrets here. Okay, so we'll just keep on looking at the walkthrough. Alright, so we've got our EC2 instances over here. So our IAM user is allowed to describe the EC2 instance. This allows us to view information about EC2 instances in the account, including instance IDs, public-private IPs, security groups, IAM instance profiles, and metadata settings. It is read-only access, meaning that we can enumerate infrastructure, but we cannot start, stop, or modify the instance itself. So enumeration, we note down the following public IP of the instance and the ID number. Okay, next we perform a simple port scan of the instance. We see that SSH is available. Huh, really? Hold on. Okay, so if we get our public IPs, we can start scanning them. Alright, so if we look through this, grep for IP, or public IP. So we'll grep for public IP. We've got a few different ones. So public IP address. And I guess we could just make up a list of different IP addresses to scan against. Not expecting this route. I mean, this is what we're here for. We're here to learn new stuff. Okay, so we grep out these IPs, and we just want the IP addresses themselves. How would we... Maybe we would cut D. Cut D by this second field. First field. Okay, so if we cut by the second field, we get the IP addresses. So what we want to do is we want to make sure that we only get the unique ones. So we would do like awk or unique. Yeah, first we would sort them. We'd sort them, and then we would unique. And so these are all our unique IP addresses. So with our unique IP addresses, I think I want to shave off the... I want to shave off the double quotes. So shave these double quotes off. And we'll also make sure to delete any spaces. Okay, and we'll put that into a file called ips.txt. Okay, so from here we can run a ping sweep. So nmap sn ips.txt. Okay, failed to resolve. How do we give nmap a file of IP addresses? I've done this before. Nmap read IP addresses from file. pn. Use the IL flag file followed by the file name. Okay, -I capital L. Okay, we could use... Oh, I mean, we could. But host is up. So we can actually... Alright, so... We managed to figure out that we do have access to these hosts, to these IP addresses. And the next thing we can do is we can just try to see which ports are exposed for each one of these machines. This is going to take a lot longer. Actually, wait. The reason, well, this is my favorite. This is my favorite flag in Nmap, the -V, which actually gives us output before the thing is before the scan is finished. Do top 100? Yeah, top 100 is probably the better way to do it. So to do top 100, we would just get rid of the port argument altogether. Okay, so most of these hosts are exposing port 110. I'm not too sure what 110 is, but I'm sure it'll tell us in just a bit. I guess we could also search for... And we're only getting port 110. TCP wrapped. Yeah, everything is 110. Port 110 is a default TCP port used for unencrypted POP3. I have no idea what this is. Yeah, it's only one. That's weird. I mean, did I... Maybe we should just look for other IP addresses. So the public IP addresses are these ones over here. And how many lines is this? Word count. So this is 60. Nice, 69 lines. I mean, I guess after we grep out the unique ones. Banner grab. Okay, let me try outputting this to nmap 1.txt. We'll come back and look at this in a bit. Because our good friend, the write-up says, we perform a simple port scan of the instance. We see that there's SSH available. Oh, you know what? Maybe we should have been running Nmap in PN mode all this time. Because some of these servers might respond to pings and some might not. That's a pretty good catch. Okay, so we'll run the same thing, but we'll run in no ping mode. Now we've got different results. So we got port 25 on some of these machines now, and I'm sure that'll tell us about the SSH port on the other thing in just a bit. Okay, so this is important stuff to note. When we run against a bunch of what are they called, like EC2 instances, we should be running it on no ping mode. Mail stuff on port 25. Because it said in the write-up it says that it finds like an SSH port on one of these EC2 instances. Although I haven't found one yet. You should pretty much always use -pn these days unless you're doing a ping scan. Yeah. It's probably the better way to do it. Because you never know what's not going to respond to pings. Is the scan 2 limited? Only the top 1,000 ports after all. I mean, I guess we could run like a more in-depth scan after our initial scan. But the reason why we're scanning only the top 1,000 ports is for speed. Okay, so it says that we're only about 5% done. 31 minutes for this scan. So we know what we're actually supposed to be looking for. We're only supposed to be looking for port 22. So let's just look for port 22. Because otherwise we might be here all day. We're looking for one that's in an open state. So grep, we'll put this into nmap p22. And then grep for open. Yeah, so there's one server that is port 22 open, and the rest of them do not have it open. So filtered. Okay, I guess after we've identified one particular machine, we should probably do like a more thorough scan of this one. So just nmap on this host, nmap target, and we'll just run this on every port. Okay, so we have SSH on this target, and I guess we can just check it out. Try to SSH into it. We don't really have any credentials though. And we don't have like a username. Well, the only thing we can guess at is like root. Okay, we're running our Nmap scan over here. And for some reason, SSH doesn't want us to interact with us. Can we? Well, it's not going to respond to pings. Yeah, these do not respond to pings. So I wonder what the point of paying attention to this target is. There was a significant SSH vulnerability recently. I can't imagine that's the root. I mean, typically that's not what we do on like these cloud pen tests. But maybe, I don't know. Anyways, we've got ads running on Twitch, so we will put on the birds. Okay, we'll be back in about 60 seconds. I just need to take a little bit of a water break. You know what? I think I might have another place to look. So we know about this particular target right here, and we've got our file where we did EC2 describe, you know, the output of this
Mr.
thing.
Hatnett, please be excused from class.
Well, Kyle,
Yes.
you hear me? You go to
Hack.
You go to
Hack.
you
Have a great day.
Hope you're having a great day. Rob Vo, hello, nice to see you here. What is up? Okay, what are we doing? We're doing cloud hacking stuff. You want to do the same cloud hacking stuff we're doing, then you want to access data secrets from HackSmarter. So I'm learning stuff. I'm learning about how to interact with EC2 instances over at AWS. So we're looking for a specific IP address. What was that IP address? This one. So this is the one with the SSH port open. Okay, and then we'll get more information about this, like 20 lines. We've got a few different ones. So public IP is this thing, and I guess we need to pay attention to the ID. To the ID of this one, because network interfaces ID. Okay. So I think we can do some further enumeration if we have the ID number of a particular EC2 instance. Let's just echo this out to ec2 id.txt. Okay, so ec2 describe is ec2 enumeration by ID number So to enumerate an Amazon EC2 instance by its ID, you can do the AWS Management Console, the AWS CLI. So we want to do it using AWS CLI. So EC2 describe instances, instant ID. I something something something. Oh, okay, okay. So the So the instance ID number is, it starts with I. So I guess what we want to do is grep by I dash. No. Instance ID. Okay, okay, here it is. So instance ID, this thing. I hope this is the correct one. Okay, and then what role do you have in cybersecurity? I mean, I used to work as a web app security tester, but I don't do that anymore. I am currently trying to be an educator, so I'm teaching people about, basically teaching people about like skills that they'd use for like CTF challenges. Also helping people get into the industry by pointing them at resources and stuff. But Sam FR, hello, nice to see you here. What is up? So this is the instance ID number. AWS EC2 describe instances. Okay. So let me just double check that this is the correct IP address. The IP address is 34 and then 36. 34 then 36. Okay, looks like the correct one. So we have an ID number, and then we also have some other stuff. So what are we supposed to do with this information here? We know that there's an SSH port open on the server. Unless there's some credentials lying around here. Okay, the in-app scan still hasn't come back. I guess it's kind of slow doing it over over VPN. So what do they want us to do with this information? Okay, so shell as EC2 user. So what are we doing here? We try to dump the user data and find a base64 string. So let's see. Oh, they're using another command. So this one is EC2 describe instance attribute. And they're looking for... what attribute are they looking for? Let me copy this and we'll take a look at it. So this is another command I don't know. Okay, we're looking for the attribute called user data. Describe instance attribute. Check a different write-up. Maybe they'll explain it better. I mean, maybe. I mean, I can just stick to this one. It's okay. It's just that I want to understand what kind of commands they're using and how we would incorporate it into like a regular flow. Describe instance attribute. describe instance attribute. Okay, so the following arguments are required: instance ID, and the attribute. So if we don't know what the attribute we're looking for is, we can't run the command. Okay. So instance ID and user data. Instance ID, user data. I mean, I suppose that if we looked at the Paku tool here, they probably have like modules that do this kind of stuff too. Okay, and we've got like a base 64 command. I guess we can just try to decode it. Bin bash echo EC2 user. What is this? EC2 user cloud goat instance password. All right. I mean, I guess we've got credentials then. Okay. We got a remote access tab. So what is the IP address one more time? This thing, okay. And what was the name of the guy? EC2 user. Okay, so we're gonna copy paste this stuff. Okay, so we can log in via SSH, and we'll just grab the password here, paste it in, and we're logged in. Amazon Linux 2, end of life is 2026. That's now. Well, that's like in a week or so. A newer version of Amazon Linux is available? Sure. So what is here? So we're in the home directory for this EC2 user. Do we have sudo permissions? Oh, we can become the root user. Okay. Yay, we're root now. Dusa, hello, nice to see you here. What is up? Welcome, welcome. Okay, so we're the root user on this system. I don't know if there's like anything in the root directory. Actually, which shell are you using? So I guess what we would do is unlikely. Oh, there is netstat. Okay, we got port 22, 111, 22, and some other stuff. I don't think there would be anything in the root directory itself. Well, authorized keys. Yep, nothing's in there. So what we're looking for on this EC2 server is we're looking for what was it? More secrets. Where would those be? Maybe in the op directory? Oh, there is stuff in the op directory. So there's like an AWS directory and an RH directory. I don't know what RH stands for. Nothing's in there though. How about the AWS directory? API tools and bin? Which one first? Let's take a look at the API tools. CFN and init and some other directory. So this is also okay, there might be some configuration information in here. That's a directory. They both lead to the same thing. Bin, init, and share. Let's move into the share directory. There's a doc directory in here? Sure. A bootstrap directory. I sure hope this isn't a rabbit hole, because there's a lot of stuff to take a look at here. Notice.txt. Certificate root certificate. Okay. CA root certificates. Something tells me that this is not the place we're supposed to be looking. Bin, init, share. So there's the API tools directory, and there's this other bin directory. Authorize keys. Okay, we've got curl authorized keys, parse authorized keys. Is this going to give us more credentials? Let's grab for something. So AWS maybe? Maybe look for a key value. Well, let's try taking a look in some other file. So curl authorized keys, and then we also have run. Okay, nothing here. And the last one was parse. The other thing we could do is we could just grep inside of every file on the server and see if we can identify any secrets. So if we go over here, so let's see, something that starts with AKI is probably going to be a user access key. So we'll just grep for every file for that pattern and see if we can find anything. Move into the temp directory and then grep recursive for the pattern AKI. To dev null. Well, we'll just redirect it into something like AWS key search. Grep R. Oh, okay. We need to look recursively in every directory. And I guess what I should have done there is I should have run that as a background process, because now I'm locked out of my terminal. That's okay. In the meantime, I can log in from another terminal as well. From another, yeah. Okay, thank you very much for following Aquaternion. Hello. And thank you very much for following on Twitch. Okay, I guess this is basically the only way we can move forward. The write-up is pointing at some sort of lateral privilege escalation by, unless there's some sort of like bucket information where we could also look. But my guess is that there's going to be credentials on here somewhere. And we can try logging in as another user. Log in from another terminal, rather. EC2 user. Okay, and password is here. Did I copy the password incorrectly? Oh, okay. I typed in the wrong... Remember, everybody, you need to type properly to be a hacker. That's a big typo right there. So, the shy. 31 typo. We've got a special emote just for typos. That's the one. Okay, so this binary file matches. So what is this? This is a data file, so we can run strings on it. And then we can grep for that pattern. Okay, so these are not keys. That's a vicious lie. Hold on, wait, what? No, I don't see the keys. Yeah, we found something, but what else could we do here? We can, well, let's become the root user again. Maybe there's something in my environment variables. There's only one user on the system. Yeah, only one user on the system. Although I guess we could access the shadow file. There's no, yeah, there's no hash for the root user. Okay, let's not be the root user and see if there's any other environment variables for this user. No. Okay, there is for EC2 there is for TC2 who typically has pseudo perms. What are we talking about? Okay, so this script sets a password for the EC2 user. There's a hash. So we connect to the server as the EC2 user, etc. shadow, etc. shadow. Well, I mean, there's a hash for etc. shadow for the EC2 user, but we already know the password. Okay. So EC2 instance profile. Oh, yeah. I mean, what could we be looking for? So EC2 instance profile exploitation, we check our identity and we see that we have the following role. The following role is CG. Oh, we can run AWS CLI from the EC2 instance. I never really thought about that. Huh. Alright. I'm learning new stuff. So on here, we can run AWS CLI. Accept your cookie. Accept your cookie. Okay, so we're running as a different user now. So we're now the CG EC2 role. I mean, So what is our username? Because I see a slash in here. Is this the entire username? So from here we can run all of our typical enumeration commands. So we can go back in here and start running stuff like user permissions. So list attached user policies, username, your username. So is this the username? Or is this entire thing the username? Yeah, it's gotta be this. Okay, study bloggers. Hello, nice to see you here. What is up? Okay, we reuse our following resource and reiterate the steps for another recon phase with the new permissions attached to the EC2 instance. Okay, we can query the metadata service. Query the metadata service. Hold on. What is this about a metadata service? Oh, it's your birthday. Happy birthday, study bloggers. And good morning from is that Dubai? So what is this IP address? This IP address is not... Because do we have access to this IP address? I don't understand where this curl command is from. Is it the controller? I don't know. I mean, we can try to curl it. We can try to ping it. Nope, can't ping it. That's why I don't like the write-up. So they don't explain this. So AWS pen testing checklist. I mean, this is probably good to pay attention to. They run AWS STS get caller identity, and then they run curl. But where do they? What is this latest metadata endpoint? Yeah, cannot resolve the host. Can't resolve the host. Okay, we'll check out another write-up. Maybe they explain better what's going on here. It's the last host in the network. It's the last host in the network? Really? Okay, so let's hope that they run some Rust scan. Shell as the EC2 user, sure. Okay, our initial foothold obtained. Let's further enumerate and complete the goal of the lab. So this is... yeah. Okay. Instance metadata service. Instance metadata service. Okay, I've never used this before, so session enumeration as EC2 user, sure. STS get caller identity, yeah. Okay, so we have the following role available. The following role available. Assume role. Oh. So wait, this CG something something something, this is a role and not a username. Let's go back. Okay, assume role. This role right here. So our actual username is this. So the instance username, the instance is our username, but we're acting as this role. So role CG ID something something. Okay, so we know there is an IMDSV1, which will lead to SSRF. What? What do you mean by SSRF? How do we know it's going to lead to that? And how do we know this? Okay, they run the same command here, so curl this latest metadata. Oh, is this available from inside? Yeah, okay, they're running this from inside. How do they know? Okay, so if we run this from inside this box, these guys have done it too many times, they make assumptions. Okay, so the other thing, I guess we could figure out, how do they know to access this IP address? We could probably figure out, what was the command to get the routing table? Or get the IP addresses that the host is in contact with. So our internet address is this, which is different from, well, and they talked about a specific role, right? So if there's a specific role, we want to take a look at what that specific role is able to do. IP route, okay, sure. IP route. Okay, so this does get us our IP address, but how do we know to... I guess we could do further enumeration against this. For instance, we could... how do we know that we should curl this? So we curl it, it just gives us a list of dates. Kitty Sack. Kitty Sack. Hello, nice to see you here. And thank you very much for following on Twitch, thank you. Okay, so IP route does get us the IP address there. So let's just try looking for AWS CLI enumerate roles. Okay, identify your current identity, sure. Enumerate IAM roles. So AWS IAM list roles. I don't know if our user is going to be able to do this or not. Maybe? So we're not able to list roles. So if we want to list only role names and ARNs, search for a specific role by name. So I'm pretty sure we can't do any of this stuff. So I wonder how they knew how they knew to do this. Okay, so what is the... Let me get our role name first. Actually, I know my role name. It's this one right here. CGEC2, CGEC2 role CG something something something. This thing. Okay, but we're not allowed to do this. I wonder if we can do this from the outside. So we'll try doing this from from the outside here. Nope. Okay, because our user is not able to do the list roles action. Can't do that. The other thing is whether or not this is like a common role. CG EC2 role. I don't know. I don't know whose name we might be referring to. So, is there like a common role for CG EC2 role? Okay, so this refers to a specific intentionally vulnerable IAM role created in CloudGoat. Oh, sure. Okay. I mean, how do we enumerate for this? So the write-up doesn't say why they're doing this. It would be better if they could explain a little bit. So we check our identity and we see that we've got the following role available. So this is the role right here. As we know, there is an IMD-SV1, which will lead to SSRF. The metadata service is available. Let's grab the IAM role credentials. The metadata service is available. Okay. So are they... What is IMDSV1? Or what is the IMDS service? It's a name that strikes fear in the hearts of my enemies. I'm sure it does. Okay, so this is Instance Metadata Service. In cloud computing, IMDS is a built-in, locally accessible HTTP service available to virtual machines. Okay, it allows applications running inside a VM to query configuration details, network settings, and temporary IAM credentials usually via the non-routable IP. So this is common knowledge. So this service does exist, and it's usually at this IP address. Okay, modern environments use IMD-SV2, which requires session-oriented tokens to prevent server-side request forgery attacks. Okay, this is way more advanced than what I usually do inside of cloud security stuff. But sure. So we need to know that inside of each EC2 instance, it has access to this IMDS service. So it'd be from over here. So we would curl the specific endpoint metadata something something, was it? Latest metadata. Okay, and this lets us know that we've got Tyler got me? Well, I mean, I wouldn't say it's Tyler that got me, it's just that I don't have experience doing sophisticated attacks like this. Or not sophisticated attacks, sophisticated testing. Hack harder, not smarter. Well, I mean, the thing is that if you've never learned this stuff before, then there's no chance you would know it unless you have the knowledge already. So what are we looking for? I'm just gonna press the I believe button. So what are we looking for? The metadata service is available, so grab IAM role credentials. So extracting IAM role credentials, so we go to the metadata IAM endpoint /IAM info. So we're the info user? Question mark? So we query the endpoint, latest metadata IAM slash, it's more than this. Slash security credentials slash this role. Okay, so what's our... slash metadata slash security what? Security credentials. Slash our ID number or our role. Okay, not found. What did I misspell? CG EC2 role something something. Not found. What if we just look at... So security credentials... Did I misspell something? Latest meta... Oh, okay. I think I've... Oh, I forgot the IAM. Yeah. We need to put IAM between here. Okay, great. So if we go straight to IAM... If we just go to IAM, it just gives you the feedback info. Not found. So this is not okay, this is info. If we look for security credentials, it gives you not found. Okay, and then we've got a new set of credentials that we can plug in. We also have a token. So the type of credentials here are AWS HMAC. We've got a different access key ID and a different secret access key. I mean, I guess what we could do is we could plug this into Kaku, because it can handle this. It can handle this kind of stuff. So I want to do a new session. Set keys. Okay, set keys, key alias, data secrets, EC2 instance. Okay, we'll copy over the access key ID. And the other thing. and the session token. So we got the session token here. Key saved to database, okay. So now we're working as the data secrets EC2 instance. So we would also try to brute force the IAM permissions. So run brute force something something, this one. Okay, and we leave it running in the background. Eventually it would get back to us. So there's so many new things that I'm learning in this lab. So first of all, I've never really done very much with EC2 testing, so that's a whole new thing I'm getting used to. And then finding out about this service right here, the IMDS service, which I'd never heard of before. And the fact that you can grab credentials from it, which is another really, cool big thing. Always something to learn. Yup, that sure is correct. Okay, so lateral movement via IAM role, configuring accesses CG EC2 role, sure. Okay, AWS configure again. Verify access. Okay, got access, let's enumerate further. So while attempting to list Lambda functions, we find the credentials of a DB user, a database user. AWS Lambda, list functions, region US East, profile something something. So they find a user, they find more credentials. Paku sounds like we were having our South American friend do it. Kind of. Well, I mean, that would be more like Paco, right? So, Lambda list functions. Lambda list functions. What is... Okay, let's, I've heard of AWS Lambda before, but is it like a different type of... Is it a different type of cloud infrastructure? So AWS Lambda is a serverless event-driven computer service. Run code without provisioning or managing servers. Okay, Lambda is running functions as a service. Running functions as a service. You simply upload your code and the service automatically handles infrastructure management. So zero administration, AWS manages operating system maintenance. Okay, so it's just like running... Yeah, running code as a service. Okay, this is still going. So when we come, after this finishes, we should see that we've got permissions with Lambda that we can go and check out. But what is the command that we're running here? So Lambda list functions. Sort of fits. In Python they're anonymous functions. They are anonymous functions. So Lambda list functions. And then it has these database user access keys. So this gets us another lateral privilege escalation as this new database user. So I'm guessing that the database user has access to the secrets manager. This is... wow. I'm gonna have to write so many notes after this is all over to cover all the new stuff that I've encountered in this. Not that I'm complaining, it's just that it's good to have access to materials that teach you new stuff. Okay, so these are our allowed permissions starting from here. Okay. And then there's a bunch of denied stuff. So most of this is denied stuff. So I don't think we need to... Well, I'll stay connected over here. We'll call this EC2 user brute force. Okay. So our allowed permissions are EC2, this stuff here, and then S3, and then logs. Huh. The funny thing is that how would we figure out that we have these lambda permissions in the first place? Because brute forcing, I mean, the Paku tool didn't find these. So S3 logs. So when we brute force, it doesn't find these lambda commands. Unless there's something I'm really not seeing here. Okay, but AWS Lambda list functions. AWS Lambda. All right, let's write a little section in our guide. In our guide. Well, I mean, they're just notes. They're just notes is what they are. So DynamoDB, there was a whole section on this particular tool in our last AWS thing. So this is going to be Lambda. I guess we should talk about what Lambda is. Lambda overview. So according to our good friend Google search, Lambda is a serverless event-driven compute service that allows developers to run code without provisioning or managing servers. So functions as a service? Lambda is a service which allows users to upload code and run it on AWS servers. Okay, so enumeration. So I guess the first thing we do for enumeration here is to list functions, which is this command over here. AWS Lambda list functions. Okay, and then so I guess we can also read this. I mean, we've got two walkthroughs over here. I wonder which one gives us more accurate information. Okay, accesses Lambda user. We continue on the instance and from the other actions from the checklist. While attempting to list Lambda functions, we find the credentials of the so-called DB user. I should probably pay a lot of attention to this pen testing checklist. And you can too, with this link. And sorry for the flashbang, everybody. Okay, AWS Lambda list functions. Can we just run the commands from Paku? Okay, you must specify a region. Oh, really? US East 1? Ah, we can run it. We can run AWS commands from Paku. That's very convenient. Okay. So, I mean, we've got these things right here. So DB user access key and DB user secret key. So we can just copy these. We can put these into, well, we can put them in Paku. If Paku can run regular AWS CLI commands, why would you not just run Paku? Well, why would you not run all your AWS CLI commands through Paku? Paku sure is a hardworking guy. Yeah, he's my best friend for cloud hacking stuff. Okay, we'll see if we can get this done in the next 30 minutes or so. So according to the walkthrough, it looks like we're pretty close to finished. Okay, so we would do, well, let me go ahead and paste in these credentials. So inside of Paku, it's like set keys. Okay, so the key alias for this is data secrets DB user. Alright, we get our access key ID. Where is that? This thing, and then the other one. Okay, and then session token. I mean, we don't have a session token, so we'll just hit enter. Okay, and then, I mean, I'm inclined to just run the brute force permissions again, but that might not be what we want to do. So, I mean, I'll just run it for fun. So, this is probably going to tell us something like we've got access with the secrets manager. Okay, lambda get function name. We have a specific function name. So list functions, and then specific function name. Okay, DB user, this thing. We have access, we're actually Lambda user. And then retrieve the secrets. So we use this user to access the secrets manager. The former checklist recommends checking these as a final recommendation in a pen test. Is this the last topic? Yeah, this is the last topic for today's stream. Okay, AWS Secrets Manager help. we found the following resource, CG final flag something something. So AWS Secrets Manager, it's its own thing. Okay, we're gonna wait for Paku to come back to us, and hopefully it was able to identify that we got access to the Secrets Manager via the brute force. If it's not able to identify it, then I don't know. It doesn't seem so good. Anyways, we'll try accessing the CLI terminal from another terminal here. AWS configure. Okay. This thing. The other thing. And default region name, US East 1. Okay, and then AWS STS get caller identity. And then we're now CG Lambda user something something. We'll rewatch with more calm. Yeah, I mean, it feels like I've been it's kind of information overload for me, because this is all like brand new stuff to me. So the Lambda user. Okay, so if we start looking for our permissions, actually, there's one more thing that I want to record for Lambda here. So list functions, list function details, and they covered it over here in the other walkthrough. This one. Yeah, get function name. This one. And I guess we should also specify that the region has to be included in all of these Lambda commands. So list function, get function. We should be attacking a Death Star. Well, I mean, maybe one day we will, with all this knowledge that we're accumulating here. Okay, Paku, 4 allow permissions found. Okay, we'll just go up to the top. So allow permissions, EC2, S3, logs. It didn't find the Lambda stuff. I wonder if I'm running this brute force command incorrectly. Facho, hello, nice to see you here. I haven't seen you in a while, but nice to see you again. Okay, so 4 allow permissions found, 4 unknown permissions found. So it supported EC2, S3, and logs. Yeah, I wonder why this didn't work. Okay, so it was the Secrets Manager. So Secrets Manager is its own thing. We'll list this out as another section. Okay, well, secrets manager overview. This is a service which keeps track of secrets. Okay, so the AWS Secrets Manager, I just want to get the official description. A fully managed service that helps you securely store, rotate, and retrieve sensitive data like API keys, OAuth tokens, and database credentials. Okay, so this is a service which keeps track of secrets such as database credentials, tokens, and I guess maybe API keys? Tokens, API keys. Well, I mean, I don't know for sure, so maybe I shouldn't say. Oh, it does say API keys. API keys, OAuth tokens. Yeah, okay. Okay. And what do we got? It's a secret keeper. It can hold any type of secret. Yeah. It could be anything. It could be anything. Okay. We can use this user to access the secrets manager. So the other thing I'd like to know is, can we actually check account permissions on here? So could we go to like IAM list groups, IAM list roles, IAM list users, but this doesn't tell you what commands you have. User permissions, IAM list attached user policies. Let's see if this works for our user. It doesn't seem to be working very well. So username CG Lambda user. Okay, every time I try to run this command, it says that we don't have authorization. Alright, well, let's run the secrets the secrets manager. List secrets. Oh, okay. There's no dash. Okay. So I guess this is your default command when you're using the secrets manager. Okay, so here, enumerating secrets, this command. List the secrets, please. Okay, description, the final flag for the Cloud Goat scenario. Value, okay, and then does it actually give it to you in that's a lot of stuff. Secrets.txt, please. Okay, 5 productions. Is your system fully running on Linux, or are you running it from a VM? Yeah, it's a VM. So this is a Kali Linux VM that's running on top of my host system. Okay, so key value. So where is the actual flag? Is there another command that I have to run to get the specific secret? Could be. Okay, we get those secrets. List secrets. So secrets manager lists secrets, sure. And then we query the value of that and retrieve the flag. So AWS secrets manager get secret value. Okay, so there's another command we need to run that's called get secret value, and we need to get the secret ID value. So the secret ID value is the thing that we found in the other thing. So value CG final flag, this thing. We need to plug this into the other command. Okay, and what is the full command? Get secret value. And what are those parameters? Secret ID. Okay. So AWS Secrets Manager, get secret value, secret ID, and then we finally finish it. Data secrets are fun, aren't they though? Aren't they? Okay, new to the channel. Should I, I'm new to this channel. I want to get into cybersecurity. I don't know where to start. Yeah, let me go ahead and give you the thread. So go ahead and go to that link. It leads to a Reddit thread where we've got a bunch of... We've got a video, we've got a bunch of different challenges, and we've got some personality tests, I guess you could call them, that help people get into cybersecurity if they're a complete beginner. Give it a look. Okay, so this is the thing. We'll put it into our notes. For Secrets Manager. So enumerating secrets, and I guess we could call this list secrets, and this is get value of secrets. Personality test? What is this, Facebook? No, it's even better than Facebook. It's... oh gosh, what is that website that everybody went to for all those personality tests? Okay. Man, this was... I've got a headache because I've been learning too many things about AWS over the last couple hours. Okay, here's our flag. Do not recall, never been my thing. Personality test. Website with all the personality tests. Okay, the heat has nothing to do with it. Yeah, the heat might have something to do with it. BuzzFeed. BuzzFeed was the name of the website. So BuzzFeed personality tests. Yeah, this used to be a very popular thing. I don't think... Is BuzzFeed still a thing? I don't know. But yeah, it is really hot. I also can't run my fan super... I'm running a fan in the room that I'm streaming from, but it's not turned up very high, because if it's turned up high, then it shows up on the mic. So I can't cool off very well. Alright, let's submit the flag. That's correct. Okay, and we're done. Not as big as it was. Okay. Okay, this is where the system identifies what career path you should take based on your personality. I just took it a minute ago, and it states Level 1 SOC Analyst and Level 2 Pen Test. Level 1 SOC Analyst and Level 2 Pen Test. You're Canadian, you don't know heat. Yeah, I guess I don't. I guess I don't. Although the summers have been very hot over here for over the last couple of years. But 5 Productions, what background do you have? Let me know. Do you have any experience with tech stuff? Let me know if you've had any experience with software development or system administration or anything. The important thing to identify when you're talking about getting into cybersecurity is figuring out what you enjoy. So let's see, cybersecurity roles. So there's offensive roles, which are red, and there's defensive roles, which are blue. So red roles are where you emulate bad guy behavior. So you test the security. For example, I guess you would test the security of websites / apps. You would write a report for the owners of the network / app. Defensive roles, generally you're trying to find out what happened after something happens. So monitor detection tools or detection software. Determine if an actual attack is happening. Or if it's a false alarm. That kind of thing. Red team all day. What path do you think would be more profitable? More profitable. I mean, I don't know. Okay, 5 Production says I'm a second year, I'm assuming. Second year IT college student. Confused on which path I should choose, since in our country it requires long experience. I'm from the Philippines, so I'm here to ask for some advice. I know some basic stuff on networking and system administration and programming. I mean, the other thing you could do is... Okay, so 5 Productions, the other thing you could do is you could try to find a meetup of people who do cybersecurity. Find an in-person meetup. Where cybersecurity people gather. Talk to the people there. And find out what they do in their job. So what I would do is I would go on to, I don't know, your favorite AI tool right here. And then let's just say that you're close to Manila. I don't know where you are in the Philippines. If you're close to any like really big city. So where are there in-person meetups for cybersecurity near Manila in the Philippines? I don't know how to spell Philippines. Just do some research and show up to some events, and then some good places to check. ISACA Manila, Hack the Box Meetup Manila, OWASP Manila. Philippines. Oh, okay. Blue Team is probably easier for the money, and there are way more jobs. There are probably way more jobs available to people on the defensive side of cybersecurity. Even before all of the AI stuff blew up, I heard that there are a lot less offensive security jobs. But anyways, just do a little bit of research, find one of these in-person groups, go to the meetup, and start talking to people. It's very important to know the right people in cybersecurity, like any other industry, because your in-person contacts can help you get jobs and education. Just one way of looking at it, remember how it's spelled. Just one way of looking at it, remember how it's spelled. Which one, Philippines, or are we talking about the red versus blue jobs? Okay, so we're going to be wrapping up in just a little bit, but let's talk about what we're going to be covering in the next stream. So today is Wednesday, the next stream is going to be on Friday. We're going to be doing more puzzle games, more networking. We're going to be looking into a little networking course. We're going to be doing our network hacking workshop. And then we're going to be looking at crypto hack, and I'm going to be teaching myself more about public key cryptography stuff over at Crypto Hack. Yay. Okay, I think it's kind of like, what? What are we talking about? The criminal path gets the most money and also has the most problems. I mean, the criminal path also gets you arrested if you don't do it. Well, even if you do it correctly, you could get arrested, so I don't know. Anyways, okay, so we publish our schedule on Reddit over here. Arrested equals a problem. That is a problem. I mean, if you enjoy your freedom, that is a problem. Okay, let's see if there is anybody from the InfoSec streams streaming right now. I'm the only person from InfoSec streams. But InfoSec streams is a very good website for learning about people who do live streaming on YouTube and on Twitch. There's a bunch of great creators over here who do cybersecurity content. But let's see who else is streaming right now. We can send you over to them, because I need to get myself some food. It looks like the best candidate is Moohoodles. And let's see what she's up to. And Drinks Cool Off. Are you streaming tomorrow? I'll be streaming on Friday, so 2 days from now. But I typically don't stream every day of the week. So Moohoodles likes to do space stuff. What's she doing? Astrobiology and space news. We'll send you over to her channel. Okay, everybody, when you arrive on her channel, if you could give this message right here, OS Frog, hip hop, hack OS Frog, I would really appreciate it. And yeah, well, we're coming back on Friday, but until then, everybody have a great rest of the week. Stay cool, everybody. All right, HackerFrogs out in 5, 4, 3, 2, 1. See y'all next time.